చేపించిన ల్యాప్టాప్ ఇది
చేపించిన ల్యాప్టాప్ అంకుల్ పాత ల్యాప్టాప్ ఇది.
మన మరి ఎట్లా లోడ్ అవుతుందా హార్డ్ డిస్క్లో?
అయింది.
ఓకే,
దగ్గర నుండి చేపించిన కదా, ఒకసారి కెమెరా చేయండి.
నిన్న పోయినా మనం
పోలే, చెప్పినా ఏమని చెప్పారు.
ఆన్ చేసిన కెమెరా.
మైక్ ఓపెన్ ఉందా?
ఓపెన్ ఉంది.
How we have to develop an appropriate algorithm or the control system for integrating sustainable energy technologies with the objective to make hydrogen as an energy carrier. We discussed that when I presented a case study, a brief case study of one of my project, which I did at University of Jyväskylä, Finland, around 2 decades before, in which we identified that there is some problem with reference to the energy level or reference condition. That reference condition, what we discussed, is going to be required for developing the algorithm for operating such type of system. So I thought I will share with you more of my experience on the same topic, so that you can get more in-depth analysis also. Okay? So with reference to that, what we were talking about hydrogen economy, we have to understand that all tools which are all engineering domain knowledge, which we are studying, basically we want to integrate that for our sustainable development, and we have seen that by 2050 most of the developed countries want to be carbon neutral. So here you can see that to become the carbon neutral, to have the decarbonized hydrogen society, okay, we need to replace the hydrocarbons by using hydrogen energy. Okay, so that is a very interesting point here. So here you can see we want to move towards the hydrogen oriented economy, and this hydrogen comes from the renewable energy sources, and at this moment, let's say we are somewhere here with fossil fuel based economy, and slowly we are moving to replace this fossil fuel based economy using clean energy technology. So here at 2030, what recently all the countries, or most of the countries, they agreed that we have to increase our renewable capacity by 3 times. So we need to have more sustainable technologies, and how they are going to contribute? They are going to contribute for the decarbonized society, and then the hydrogen. That's what we were discussing in the last lecture. Okay, so now here you might have got a very high level overview why we were discussing that, why it is important from the engineering perspective, right, or considering the multidisciplinary perspective, when we want to move towards the hydrogen oriented economy for decarbonized hydrogen society. And very shortly, what we discussed in the last class about the algorithm, I am going to present that algorithm which was in real operation. Okay. this is again a very high level information here. And I want to continue our yesterday's lecture today also, so that you can have good idea in integrating the domain knowledge. So in yesterday's lecture, we have the focus on making hydrogen as an energy carrier. Correct? So at this moment, our hydrogen is mainly coming from these sources. Okay? So it means that hydrocarbon reforming is contributing significantly for hydrogen production at this moment. Around 95% hydrogen is coming from hydrocarbon reforming. But in the previous slide, we have seen that we want to make our society decarbonized. To make the decarbonized, we have to replace the hydrocarbon, and hydrogen can be a good energy carrier. But now we are participating in a course which is focusing on sustainable technology development. Of course, we are trying to learn about machine learning implementation in that one. But first we have to see that how these technology developments are happening. So here you say, to get the hydrogen from the clean energy sources, those are the renewables, solar photovoltaic, hydropower, wind. So those are basically going to be used through the electrolysis process by getting the electrolytic hydrogen. So that electrolytic hydrogen, when we are using these sources, we don't have any hydrocarbon contribution. Right? So it is going to contribute very effectively towards the zero carbon society. At the same time, in some countries, they have the nuclear electricity also, and that nuclear electricity can also be used, and of course that heat, which is our plant, can also be used for reforming of, let's say, biomass, or maybe solar thermal can be used for getting that. But overall, the objective here is that what we discussed in the last lecture, making hydrogen as an energy. Now, I also told you briefly in the last class that when we have this hydrogen as an energy carrier, okay, it can be used in multiple sectors. For example, transport sector, building sector, industry sector, and so on. So when we consider this hydrogen, right, that hydrogen is a very good energy carrier, can replace hydrocarbon or natural gas. Right? We can use this hydrogen with some slight modification in internal combustion engine. So now this is a very interesting point from the engineering domain knowledge point of view. We know that our most of the transport sector is based on internal combustion engine, in which we are using petrol, diesel, but in place, so they are contributing towards the CO2 emission, significant contribution, and we have to reduce that, and we have to use the engineering knowledge for that. So with some modification into the internal combustion engine, we can use this hydrogen as a fuel. Last year, I had the opportunity to participate in the European Union Hydrogen Week at Brussels, Belgium. And what I observed that most of the leading automobile manufacturer of heavy-duty vehicles like Scania, Volvo, and all these manned trucks, they are modifying their internal combustion engine in which they can use as a hydrogen. So now you see how some points what we discussed yesterday, how they are going to be implemented in cooperation with the industry. Now let's point here, that one point I have shown here, transport sector, but another very interesting point we will focus on that one, that is the fuel cell. Many of you already aware about this electrochemical reaction, fuel cells, and these fuel cells can be used for many applications, transport, stationary application into the building, and as well as in the industry also. Okay, so now we will come very short very soon about another algorithm also. So don't worry. Okay. Now what I was mentioning yesterday, hydrogen is going to be required mainly for the process industries also. Why I mentioned? Because we are going to require fertilizers, and fertilizers require ammonia, and for production of ammonia we need hydrogen. Is it okay? So it means that for our sustainability of our sales and for our next generation, we need to have sustainable food, and to get the sustainable food, we need fertilizers, and for fertilizer we need ammonia, and we can get the green hydrogen through this electrolysis. So you see how all the things, how they are integrated with each other. So this picture, it is providing you some idea about the supply of hydrogen and the demand. So if we go previous slide, in the previous slide, this ICNG technology is well-established technology. Similarly, this process industries, they are also well-established technology, but the fuel cells, they are not well-established technology. So, how fuel cells, they are going to contribute in different application of sustainable technology development, and then how we have to control them, or how we have to use available data for doing the autonomous operation of such system that we are going to focus. Okay, so let's say for your assignment or for your exercises, if I give you a task to develop an algorithm for such type of system, I believe that after this lecture, you will be in a position to provide me a flow chart of the algorithm. Right? I know that you can do a lot of programming, but if you can make a flow chart based on your mind on the paper, that will also be quite good and good learning also. Okay? And I'm not sure that all of you are going to appear in the examination for the credit or not. No. So, I mean, for me, yeah, I have one suggestion here. Like if all the participants, they are interested, like to participate in, let's say, some quiz or some assignment or whatever the process we will follow for the evaluation, then all of you will get the credits. Am I right? So, then why not you do that? Because it is not going to be like very hard, but it will be more like an innovative thinking maybe. If you are interested, so we can organize, and there is not those who are going to participate, everyone is going to pass. That is okay. Don't worry about that. Nobody is going to forget. Okay, but to participate is also very important, because then we just say pass and people don't have to. So think carefully on that. Okay. So then of course you will get the grades also. Okay, so that is what we do. Okay. So now here we are talking about the fuel cells, and this is the new, not the new, but is an upcoming technology. And I believe that during your undergraduate courses, you might have studied how this electrochemical reaction it works in the fuel cells. Based on that electrochemical reaction and the fuel which we are using, there are some classification of different type of fuel cells. Okay? So for example, when we are using pure hydrogen, which is going to come through electrolytic process, in which we are going to use sustainable energy some of our engineering knowledge is making methanol, ethanol by injecting hydrogen in that one, and we can use direct methanol. And most of us, we are using portable electronics devices. For the portable electronics devices, direct methanol fuel cell can be used for supplying the power. Okay, so that is also a good point. This next section here, basically all these are hydrocarbon gases. So they are going to contribute towards the CO2 emission. So, but we know that at this moment we may not have the infrastructure available for the pure hydrogen due to the safety issues and many other things. We can use this hydrocarbon gas with injection of hydrogen more, that we call it as hydrogen. Then that hydrogen can be used in solid oxide fuel cell or molten carbon fuel cell, and those operate at very high temperature. So you will get some information that how we have to develop the control system or algorithm for that. So this molten carbonate and solid oxide fuel cell, they operate at very high temperature, so they can be used as combined heat and power. So if suppose we are in the cold climatic countries where heat requirement is necessary for our survival, otherwise people will going to die. So such type of fuel cells like molten carbonate fuel cell and solid oxide fuel cells, they are required. So now here, coming back to the fuel cell, can be used in different applications, portable, transport, stationary, and so on. And in this transport sector, you might have observed that, of course, for the road I mentioned very briefly about, but in the maritime sector also, and in the aviation sector also. Okay, so there is a big potential of this. Now, I just give you the very high level overview. Now, coming back to the problems which we are going to face and how we can use our knowledge for that. So we have seen that how we are going to get hydrogen produced, how we are going to deliver the hydrogen, how we are going to store the hydrogen, which type of fuel cells are going to be there, and then when we are going to integrate them, what type of control algorithms are going to be required, and for that we need to do the research and development, and then only we can do the technology validation. So now, being an researchers, you have the opportunity to utilize your domain knowledge if you want to contribute towards the hydrogen economy, maybe in a sector, let's say, on hydrogen production, for example. So in hydrogen production, that is the green hydrogen is getting the energy from the renewable energy sources. So you will need the information related to the prediction techniques to get the idea how much renewable energy production, maybe from the wind turbines or the solar photovoltaic system, is going to be there, and then based on the electrochemical characteristics of electrolyzer, which we can use as a technical or physics-based modeling, which is prediction modeling, and we can get the idea of correct. And with reference to that, because I will share with you some papers about the prediction of the solar, prediction of the wind. Okay, many of my students study, and in those papers, the algorithms are there, all the predictions are there. You can use it. So there you can see that we got this one, and on that, if we put the modeling of electrolyzer, we will get that how much hydrogen production is going to be there. Right? So here you see how you are going to contribute your computer engineering knowledge for getting the understanding of hydrogen production. production, which is very important for doing the policy work or meeting the plan. So after getting the idea of the production, we have to see that at what rate it is going to be produced accordingly. How we are going to store it, how we are going to deliver it, and where the application is going to be there, and then doing the technology validation. So here you can see in such type of system, when we are talking about the integration, that is the system integration. So when we are talking about the system integration, so different type of electronic components or the power conditioning devices will be required. Okay, so here you can use your knowledge, let's say some of you are from the electronics background, how you can develop the power conditioning devices for the specific applications. Okay, because for every application, the device component which we need to design is going to be very, very different. I will explain that. Okay, so there you can see that your electronic engineering knowledge, how it can be useful for designing that system components when we want to do the integration. Yesterday we discussed about the safety laws, because hydrogen is highly flammable and you have to be very careful. So safety is important, and then on top of that, always we need some standards. Those without that different one, right? Always there are some standards. So the course and standards, they only you can move towards the hydrogen economy. So now here you can see that if we are planning to make our society decarbonized by 2050, and already we are now in 2025, next 25 years are remaining, so there will be huge number of requirements of engineers who can contribute towards the decarbonized society. So while teaching to your students, you have to give the focus that how the big requirement of engineering professionals for the next 25 years is going to be there, and in which way. Yesterday, I was reading one article which was published by International Energy Agency, and I don't remember the exact figures, but the conclusion is that the existing electrical network of India, how it is going to be extended by that time within the next 10 years. Means that you see, all the power lines what we have, they are going to be increased by maybe double times in one decade. Let's say, my number may not be correct, but it is going to be very fast, right? So it means that for that we will be requiring the engineering professionals. Okay, so it means that core engineering domain is going to come back again. That is true. Okay, so like now you got a little bit high level overview about hydrogen economy and how we can quote. Now I am going to give you a very specific case about algorithm and how that algorithm has been developed by me and my team 25 years ago. Okay, so this is a now very interesting and real operational. Okay, here you can see that we are integrating renewable energy sources with what objective? With objective to store the energy in the form of electrolytic hydrogen. It means hydrogen is going to work as an energy carrier. So here I am going to share my experience of working on this project. I was leading this project, two projects to develop the same. One was in Canada and one was in Finland. So in this project, the idea was that if we are going to use wind turbine and solar photovoltaic sustainable energy technologies how these renewable energy systems have been integrated with the objective of hydrogen production and storing. And then here I made one point that should be hydrogen utilization also. And then when we are integrating all this system, how this system is going to perform based on the control system or the algorithm which have been developed and implemented for the operation of this system and then operation and performance analysis. And then of course I am going to provide you the coordinates. Okay, so this is a very interesting project and I feel very happy that I did this work maybe around 25 years before, and now we have seen in this hydrogen economy slide by 2050 our huge fossil fuel based economy is going to be replaced with hydrogen based economy. So it means that some of the outcomes from this project is going to be useful for that. Okay, so I feel very glad that the work which me and my team, what we did 25 years before, is going to make significant contribution. Okay, so that is a, so whenever you want to do any research or any work, you have to think that how that work will be useful for next 25 years or 30 years, right? And maybe more from the practical implementation point of view. And similar approach you need to follow in your teaching also. Now, the question in your mind may come that we want to store the energy in the form of electrolyte hydrogen. We can use battery bank also. So, compared to battery bank, storing the energy in the form of electrolyte hydrogen is going to be more complex than conventional battery system. That is true. Okay? That is true. So, but then what advantages which we are going to get? What advantages which we are going to get? Then we know that most of the technologies, they are available in the market. But the big challenge is that how we are going to integrate them. How we are going to integrate them, right, for such type of system. And when we want to integrate them in such type of system, then the expertise of electronic engineering, power engineering, computer engineering is required. Because we need to have intelligent power conditioning devices which can help us to overcome the intermittency or to integrate the components which have different operational characteristics. Okay, so that we are going to discuss. And then, of course, we need to have proper understanding of control strategy or algorithm which can help us to have the operation of such type of system in which the key focus is to store the energy in the long term in the form of electrolytic hydrogen, which I am going to discuss with you that have been developed and successfully tested. Now, the point which we missed in the last lecture about the energy reference level, that also, or reference condition something, that also we are going to discuss here, and also the algorithm. Now this is a real system. This is a real operational system. And now you have to see that how your computer engineering background and electronic engineering background, which you can utilize here. I will explain you as step by step. Okay. Here, the reference DC was happening. Means whenever we have any system, right? So because all of you are very qualified, and you know that to operate any system, we need to have some reference level. So in this work, this reference DC bus having the reference DC bus is going to help us for defining some minimum maximum energy level value which we discussed in the last class for operating such kind of system. Is it okay? Now, yesterday I mentioned you, here we have the wind turbine. So this is a real project, okay? So it's not like a simulation study or computer based work, it's a real work, okay? And of course, when you do the real work, we need to have the real power conditioning devices, real operating control system, and of course, then we are going to collect the data also. Okay? Then of course, we need to do the data analysis also, and then that data analysis then we get it into the machine learning. So here, this energy level at the DC bus have been taken as a reference condition, and on that, this wind turbine, which is a three-phase permanent magnet synchronous generator, has been taken. Its output, what we discussed in the last class, it was variable voltage, variable frequency. So by using appropriate power conditioning devices or regulators, we convert it at an appropriate voltage and appropriate DC voltage, okay? And that we connect on the DC bus. Similarly, solar photovoltaic also, okay? Different operational characteristics, different type of power conditioning devices will be required, the regulators will be required to have the appropriate voltage so that we can connect here to the DC bus. So some of you are having electronic engineering background and might be working in developing some electronic components also. So here you can see that the components which are going to be required here in this case is mainly the DC-DC converter. And the role of the DC-DC converter to operate this photovoltaic array at maximum power point. And I believe that even the computer engineering students, they might have did this course in their bachelor's about electronic components also. So you know that when we are designing the DC-DC converter, if we don't do the proper calculation in finding the sizing of the system components, for example, inductor size, capacitor size, right? If you are not selecting properly, then it can operate under the discontinuous conduction mode also. Okay? So then this system is going to fail.
Currently there are standard direct bugs available, we can directly.
Correct. So always we need to find out this will operate under the continuous conduction mode, but at the same time we have to see that those available market DC-DC converters, right, those are having appropriate capacity of the photovoltaic panel which we are connecting there, or otherwise we have to make the parallel connections on that one also. So from learning point of view here, right, they are commercially available also, but we may need to make some further changes with reference to the control system or PWM switching signals of this regulators or DC-DC converters also. Is it okay? Because I think if suppose we have a photovoltaic panel or photovoltaic array, we are connecting not on the DC bus but on the AC network, then those DC-DC converter and then DC to AC converter required now as per the regulation to provide reactive power in real time to maintain the voltage quality. So to make that reactive power on that real-time operational data parameters, you will be in a position to change the switching signals of DC-DC converter and DC to AC converter for providing the active power and reactive power. Then your control algorithm and data knowledge is going to come into the picture. But in this case, we are not having the AC here, we are having the DC only. So we are only taking the active power. Okay? So, but that is a very good point here. So now, these primary renewable energy sources, their prediction output is you can predict by using wind speed prediction and putting the modeling of the wind turbine here, taking into account the power speed characteristics, and you can predict here. Similarly, with the photovoltaic system also, taking the incident solar radiation and making its prediction and taking the operational characteristics of the photovoltaic, you can predict how the photovoltaic is going to be there. So here you can see that maybe some of the tasks you will be learning from practical sessions, that how we have to do the prediction. So you can use those prediction techniques for predicting here the wind turbine. Similarly, here I mentioned you, this is going to be the standalone system. In the standalone system, of course, we are going to have some specific dynamic load. Okay, so based on the historical data of the load, we can predict that how much load is going to be there. So based on those prediction of the renewables and the load, we can predict how much excess energy is going to be there, and then slowly I will come that excess energy by using the modeling of the system components, we can predict that how much hydrogen is going to be produced. Is it okay? So now coming back to the algorithm here, or let's say the high level, we have the energy level at the DC bus here, okay, and objective is store the energy in the form of electrolyte factor, supply here, load here, and of course then we need some master controller with some algorithm here. Is it okay?
Production of hydrogen is the process variable which we need to control, sir.
We need to maximize the hydrogen production and at the same time fulfill the load demand. Because I will explain, you will get that to that point, don't worry. So now here in this master controller, it needs all the information to be wind turbine, photovoltaic output, electrical load output, requirement, energy level at the DC. Okay? Now, when this master controller has to make the decision to start the electrolysis, it cannot have the continuous process of the electrolyzer in such type of system. So to start the electrolyzer process under this algorithm, right, when we have this input here, load output, we know that, energy level at the DC bus, we know that. So making the relative comparison, if this master controller or its algorithm decides that we have or this system has this much access, based on that it can send the information to the microcontroller, which is basically controlling the electrolyte. So the microcontroller got the information or the feedback from the master controller that during a certain time period, how much excess energy is going to be available from this primary renewable energy source with reference to the load. Based on that, this microcontroller will send the information to the microcontroller. Then this microcontroller can send the information or the signal to start the process of the electrolyzer. To start this process of the electrolyzer, we need to have appropriate power conditioning device. So this appropriate power conditioning device, in this case, this is the DC bus, this is also the DC, required the DC voltage, but we cannot connect it directly because we need to control the power flow also to the electrolyzer based on how much excess energy is available, as well as for the isolation also, we need here DC-DC transfer. And students or the participants, I should not say the students, but the participants, because already you are of a master level maybe. So here you can see, then this microcontroller based on this one do the switching signal will, right, for transferring that excess energy in that particular time period. Okay, the time period also need to define. Now you got the idea how the, because here I mentioned we have to define some minimum and maximum. Otherwise, if we go below the minimum level, system is not working. And above maximum level also we need to put some limit always. So you got the idea that yesterday when we were talking about the algorithm, so that how that algorithm has to be built. And it was developed by my team to define it. Okay, and then we implemented that, and I will show you the real operational result. Is it okay? Now, when we are sending that excess energy, right, to this DC-DC converter, and of course, then that excess energy with reference to the load available from renewable energy sources, taking into account the energy level at the DC. When that excess energy is going to the electrolyzer, so what is the role of electrolyzer? The role of electrolyzer is to produce the electrolytic hydrogen. Why? Because we are storing the energy in the form of electrolytic hydrogen, and in the first slide today we have seen that by 2050 we want to make our society decarbonized. To make our society decarbonized, we may use hydrogen as a energy. And that is the key objective of our board GIAN course of sustainable energy development. Is it okay? If you are not able to understand, just please feel free to stop. Okay? So, because this was a very demonstration project, because whenever we want to do the research, right, always we have to see how we are going to demonstrate the technology and the work to the stakeholders also. Okay? So the stakeholders, which may be general public, policymakers, professional engineers, those who are working on energy policy also, so they can give the idea, right? They can suppose some type of pilot system it is working, right? Then how we can think from the bigger picture of the. Okay? So that was also the objective behind this project, not only to do the academic research in the lab, right, but to engage the stakeholders and the common public so that they can, for industries also, so that they can get the knowledge and information of such type of things. And then accordingly they can think to develop the industry policy implementation. Now here this electrolyzer, it was alkaline electrolyzer. Okay, that is a very important point. So So I'm not sure that how many of you people are aware about the different type of electrolyzer. So this is a alkaline electrolyzer, which is a very well established technology, which is widely used from country to country. So this alkaline electrolyzer always it needs constant power. Always. But now technology is changing, market dynamics are changing, new renewable intermittent technologies are coming. So then further research work and demonstration work is happening to replace this alkaline electrolyzer by using proton exchange membrane. Some of my students, they did the work on proton exchange membrane electrolyzer, and that fits very well with the smart grid. I will explain you how it is going to fit with the smart grid, because we are trying to use this machine learning for the sustainable. So, and that work which my students they did on this equivalent electrical circuit modeling of proton exchange membrane electrolyzer that have been highly recognized by Siemens also, and then Siemens they are using that modeling in their work also for doing further analysis of the sustainable electrical energy system in which we are going to have one load as an electrolyzer. So you can see that how the work which we should do and how it should be useful to the industry and the society. From that point of view, always we have to proceed further. Of course, some of the students they are having the background on or working on let's say in medical engineering, so for them it may be little different, but they have to think, let them know from high level point of view, whatever the work they are doing, how it will be useful to the society. So maybe now we will take a coffee break, 15 minutes, and then again we will start, okay? Because we need coffee. Is going to be replaced by using proton exchange membrane electrolyzer. So this proton exchange membrane also. Now here I will put that point with reference to the smart grid. In smart grid we are trying to integrate information communication technology together and also doing the demand side management and energy efficiency. In that condition, if we are going to put in place of alkaline electrolyzer, proton exchange membrane electrolyzer, then that modeling of the proton exchange membrane electrolyzer is going to be very useful for finding out the opportunities for demand side management and conditionally transferring that intermittent renewable energy for producing the electrolytic hydrogen. Now, we know that this alkaline electrolyzer is operating at atmospheric pressure. Then when there is a buffer storage tank here, this buffer storage tank is full, then this compressor starts and compresses the hydrogen at a particular pressure and store it. Then the question will come in your mind that this compressor is going to require the energy also. That energy is again going to come from the DC bus, and therefore the energy level at the DC bus is going to be fluctuating. It means that master controller is getting the dynamic data with reference to what? With reference to changing the energy level at the DC bus, with the not only with the consumption of the energy from the to the electrolyzer, but also the consumption of energy into the compressor, and at the same time this master controller is having the real time data on wind and solar photovoltaic production also, and on the electrical load production also. Then at the same time, here you can see that then this master controller has the duty, right, to predict the wind and photovoltaic production for next couple of hours also, next couple of hours production of the requirement of the electrical load also. Based on that, then this microcontroller can do that based on the prediction values, some decisions, okay, how the energy level at the DC bus is going to change and how the hydrogen production is going to be there. Now here you can see the beauty that how we are going to integrate the prediction techniques in operation of such type of sustainable energy system, in which we want to make it completely carbon neutral from the process point of view. Okay, so it means that the input is carbon neutral. Okay, of course, for the production of those equipments there may be some carbon process also, but we are not talking about the life cycle process. We are talking only from the operation process point of view. So from the operation process point of view, taking a TT which we need to implement here, right, and here also, and then getting here, and based on that, of course, the load is going to be here, hydrogen is going to be produced, and here the energy level at the DC bus is going to be changed, so that we need to predict. So based on the energy level at the DC bus, what we are predicting, right, who is going to do that one? And then accordingly checking the condition that how much energy is going to be provided to the DC-DC converter, to this microcontroller, but at the same time taking into account the energy consumption at the compressor, and we will get the idea at what particular pressure how much capacity of hydrogen is going to be stored for next 1 hour, 2 hour, or 1 day or 2 days. Is it okay? So that's really interesting here. Okay. Now we will come from the utilization point of view, because yesterday we discussed this one, okay, but yesterday due to the time limit and I was also tired, so we were not in a position to get the complete focus on the control algorithm. But now here, with the help of this diagram, you are in a position to get the understanding how the overall algorithm and the control system is going to be operating, and how you can use your machine learning techniques for that purpose also. And then this is a very complicated work, okay, even it may require, if you are interested, one of you can do the PhD work on this topic also, because it is a very intensive work. Now we will come to this point. We store the energy in the form of electrolytic hydrogen. So that electrolytic hydrogen can be used for different applications also. What we have seen in, before the break, we can use in the automobile sector, process industries, fuel cell, stationary applications, and so on and so forth. So let's say when we are doing some project work and doing some demonstration, so we have always some limitations also. So in this project, the focus was that to have this standalone system and with autonomous operation. So we will try to utilize this stored energy in the form of electrolytic hydrogen as a fuel, either into the fuel cell or into the internal combustion engine coupled with electrical generator. So let's focus first on the fuel cell. So fuel cell, again, it is an electrochemical device, and in which we are going to utilize the stored hydrogen that is the pure hydrogen as a fuel also. So when we have to start the operation of the fuel cell, that again has to be decided by the master controller. So how this master controller is going to make the decision? So this master controller is going to make the decision based on some input conditions. So what are those input conditions? How much energy is going to be available from this primary renewable energy sources, how the demand is going to be there, and based on that we have to see that how the energy level at the DC bus is there. If suppose energy sources with reference to the load and by defining some strategies of the energy level at the DC bus, it means that we don't have the excess energy. It means we are not in a position to produce or to store it in the form of electrolytic. It means that now we have the deficit, we have to utilize the stored energy in which form? Hydrogen form, for making our system more sustainable power, to operate more sustainable manner by using this stored energy. So based on all this operation, based on this all operational parameters, then this master controller takes the decision to start the fuel cell operation and provides hydrogen as a fuel, okay, and to supply the power to the load, and when it is supplying the power to the load, because due to the deficit, energy level at the DC bus is also going to be changed. Then here you see this master controller, when it sends the information to the microcontroller, so this microcontroller specifically for this fuel cell, right, and then fuel cell, it is DC device, we cannot connect directly here, so we need DC-DC converter here also for the eject. Okay, so this boost DC-DC converter switching signal has to be controlled, as well as the supply of the fuel, that is the hydrogen, is need to be controlled for fulfilling the load under the deficit conditions. Now you see, from the standalone operations point of view, how our algorithm needs to be adjusted. It means at one condition, excess energy, second condition, excess energy available from renewable energy sources, second condition, deficit of energy available from renewable energy sources with reference to the load, taking into account the energy level at the DC bus. Based on that, then algorithm has to take the decision, right, and then accordingly start the operation of the fuel cell, provide the supply to fulfill the load under the dynamic condition. So this is a very interesting and dynamic work. In such type of work, we can make the decision by taking the real-time power approach also. But here we have the focus on energy level at the DC bus. It means that it is the decisions are going to be based on the energy, not on the power. So when we are going to make the decision based on the energy level, we need to implement prediction techniques because time is there. So regarding, let's say, for half an hour or 1 hour, whatever time period we are considering, during that next 1 hour period, we should have the information for the prediction of this renewables, prediction of the load, then based on that how the energy level is going to be changed, and then accordingly this master controller has the information. So we are, let's say we are on the deficit side, that how much time this fuel cell operation is going to be there. So that controller should have the capability to have some hour ahead or 2 hour ahead, 15 minutes ahead information on the circuit. Now here, to to get that 15 minutes or 1 hour ahead information, we can use any technique, statistical technique we can use for prediction. Conventionally we use that one, but now we can use any other artificial intelligence technique also. So you can see here how we are doing the marriage between machine learning techniques for this sustainable energy technology, so that their marriage remains sustainable. If there is going to be problem, then there will be diversity. So we don't want that one. We want to have the sustainability. Correct? So you have to consider those points here. So I believe that many of you may be quite good expert in machine learning techniques, prediction techniques. So you can try to implement in such type of projects also. Then another very interesting thing is that this fuel cell technology, what we are looking here, is still not very well established technology from the commercial operational point of view. Why it is not? Because this is the electrochemical device, and in that platinum is used as the catalyst, and we know that platinum is very expensive, right? Due to the cost of this is very high. One point. Second point, to operate this fuel cell, there are different operational parameters. For example, humidification level, moisture content level within the membrane, or transferring the hydrogen ion from anode to cathode, so on and so forth. So all those things we need to maintain, or if we are not in a position to maintain that, our fuel cell will get damaged, and when fuel cell get damaged, in which platinum as a catalyst, it will be very expensive. So we can say that this technology is still at the learning stage, or maybe at operational stage to get it more mature. Okay? So, but in place of fuel cell, if we use internal combustion engine, in which we can use the hydrogen as a fuel and coupled with electrical generator, then also we can do that one. So that was the second option of this project. This one was the first option, and this one was the second option. But most of the focus of the work, it was on this part. Okay? So this is a very, very interesting high level flow chart, maybe I can say, of this system, which was operational real time. Now here I have included a single line diagram for more clear understanding of the system. With the help of this single line diagram, you can see that this is a small system, and objective was here, we have the target load of 5 kilowatt peak, and to fulfill that target load of 5 kilowatt, okay, why we selected the 5 kilowatt? Because if we consider cold climatic condition, for a typical house, 5 kilowatt is the typical load. Okay, that is the reason here. Okay, and it is, we just want to test this system also. So here, if you can see that maybe I think it is not coming, the full picture is not coming, we have to reduce it. But here the DC bus, which is at the 48 volt, and on that integrated through power conditioning devices on the DC bus. Then we have the master controller here. Master controller has all the information, okay, and then based on that the decision has been taken, and then information sent to be to the buck converter. The capacity of the buck converter, it was the 5 kilowatt, right, how much excess energy is there, and then sending that information to the electrolyzer, producing the hydrogen. Okay, so then of course we need to have purification and so on, then we are storing that hydrogen. Okay, and of course then this master controller, I think it has been more zoom, not coming completely into the picture. So this master controller sends the signal to the electrolyzer controller also, and then in the second phase, when we don't have the excess energy from this primary renewable energy sources, then this master controller sends the information to this fuel cell controller, and then fuel cell controller utilize the hydrogen as a fuel GIAN, okay, and as a fuel into the fuel cell system, and then provide the power to the boost converter to the DC bus and on the to the load. So you see the diagram which we have seen in the previous slide. So in a single line, how we can represent that one here. Now, some of you might have got some idea in your mind. When we are talking about fuel cell as a sustainable technology source, and we are using hydrogen as a fuel here. So through your basic engineering chemistry, we know that for the operation of the fuel cell, we need oxygen. Correct? Without oxygen, the process cannot be complete. So here, you can see that compressed air has been used as the oxidant in the fuel cell. But in the second condition, which may come in your mind, that when we are doing the electrolysis process, in the electrolysis process, hydrogen is also produced, oxygen is also produced, and that oxygen is of really very good quality, or the medical quality I can say. So if we capture that oxygen here and use as the oxidant into the fuel cell in place of compressed air, so naturally the performance of the fuel cell is going to improve. Very simple. In place of compressed air, if we use pure oxygen as the oxidant, performance will improve. So now here, considering your machine learning approach, we can predict from the electrolyzer, based on this electrochemical reaction, how much oxygen is going to be produced and how much quantity of oxygen is going to be required for the fuel cell operation during the deficit of energy of particular that condition. That is going to be a quite interesting to see here, right? So maybe you can give this topic to your students also, right? Suppose you want to use some prediction techniques for predicting how much oxygen is going to be produced by this alkaline electrolyzer under some circumstances. Of course, we need to define, right? And then whether that produce oxygen in addition to hydrogen, how we can use here as the oxidant into the. So here you see how you have to think out of the box in utilizing your learning for sustainability. Then I hope that it is clear from this picture. Now we go to the second. This is a very interesting diagram now. In the first phase, what I was explaining to you, that oxygen, which was byproduct from this electrolyzer, which went to the atmosphere. If you remember correctly, if you are observing carefully in the previous slides, we sent it to the atmosphere. But in the second stage of the project, this oxygen also purified and compressed and stored. Is it okay? And then that have been utilized as the oxidant into the fuel. And then naturally, very simple, anyone can say that performance of the fuel cell will improve because we are not using compressed air, we are using pure oxygen. So naturally the process will be much more efficient. Now, coming back to this complete picture into account here, this picture or this diagram, I will explain you from the smart grid concept point of view. Okay, and a smart grid in which we are integrating all information communication technologies together with the objective to integrate more and more intermittent renewable energy sources and to make our energy system more sustainable. To have this microgrid operation, some of you might have studied in your undergraduate or in your master level course. We can operate such type of system using either AC microgrid approach or DC microgrid approach. AC microgrid approach, conventionally, it is quite good, but from futuristic point of view, when we are talking about hydrogen as an energy carrier, electric vehicle charging, so decentralized DC microgrid will come into the picture. That's what I feel. So this architecture of the complete system is based on DC microgrid architecture. So DC microgrid architecture operation mainly depends on what factor? Any idea? Mainly it depends on sustainability of the voltage at the DC point. If we are not in a position to keep the sustainability of the voltage at the DC bus, the DC microgrid architecture will fail. How many of you are aware about the group functionalities? Okay, I will explain you. So group functionalities are widely used in managing the power balance between existing sustainable or existing electrical energy system for its sustainable operation. Okay, so within that we know that active power and frequency fluctuations are there. So active power prediction is going to be very important, and that active power prediction can be correlated. So for how we will do the active power prediction, conventionally we are using statistical methods for that one, but now we have the all advanced technique, let's say machine learning techniques or regression based techniques and so on and so forth. So based on that, when we get the prediction of the power, real power I am talking, we can see that how the fluctuations of the frequency is going to be there within the network. So that fluctuations of the power within the network, okay, is going to depend on intermittency of renewables, load dynamics and many other things, but we have to maintain the sustainability of the power within the network. So by using this group functionality, let's say the physics based group functionality, to implement with this prediction techniques for developing or making the prediction of the controllers of the conventional generators. And when we are doing that, it means that we know that how much input power for the conventional generators are going to be required. Is it okay? So this is a very interesting point. So that is related to the AC microgrid, but here we are talking about the DC microgrid. So I will briefly try to explain you here. So when we are talking here load dynamics, okay, this load dynamics which is going to be changing with reference to the time and which we can predict, okay, and of course in your practical classes you are doing some understanding you are doing some understanding of the prediction technique. Similarly, you can do some prediction of renewable energy also, and how the variation is going to be there. So this variation, right? So this prediction basically you are doing through using, let's say, the machine learning techniques. Maybe I think we can resume it. Resume the maybe with the help of this projector. Right? Oh no, there is not less than that. No? I was trying. I cannot change the value. वन एमपी कर दो, कम करो VGS कर दो. हाँ बस बस मिल जाए, 55 आ गया. वेरी गुड. हाँ 55 पर विजिबल है कि नहीं पीछे से? No problem. Don't worry. I will let's make it 100. I will make it a little more visible. Good. So, good. So, what I was telling you here with reference to the system which we are talking, and I was trying to explain you about AC microgrid approach, and I was trying to explain you regarding the group functionality. Okay. So this group functionality conventionally it is used for changing the input to the turbine, which is basically coupled to the generator, and when this generator is providing the power which is fluctuating with reference to system. So when this power is fluctuating in real time, so naturally the real time frequency is going to fluctuate. So here you can use your machine learning techniques or statistical techniques or prediction techniques on predicting based on the variation of the load here on renewables here, that how this change in the frequency is going to be there, and conventionally we want to make this change in the frequency to 0, right? To make this frequency back into the 0 in the fraction of seconds of time, we need to have some controller which can control the fluid flow or steam flow of this turbine here. Okay, so you can see that the conventionally, okay, we are using this droop functionality. If I take the change in the frequency on this axis and power on this axis, so something like that. So droop functionality will be there. So this conventionally, this droop functionality is used into the AC microgrid. But now if we come back, if we come back on this DC microgrid here, so that technique is not going to be used. So this technique now, this is going to be the future in my opinion. Okay, in my opinion, especially for the decentralized application like electric vehicle charging station or maybe for the hydrogen energy system also, this approach or this architecture is going to play the major role. In this architecture, here we have the DC bus, here we have the voltage sustainability. Here on the AC microgrid, we have taken the change in the frequency sustainability, okay, or change in the frequency to bring it back to the sustainable value. That's what we considered here. But here in this case, it is going to be the change in the voltage on the DC bus. So how that change in the on the DC bus voltage on this DC microgrid is going to be impacting with reference to the change in the renewables input, change in the load, okay. But in this condition we have taken the hydrogen also, so we have to take that electrolyzer as a load also. That's why I mentioned earlier, if you remember correctly, one of my students who did the modeling on proton exchange membrane electrolyzer which can operate on the intermittent level. So that modeling is going to be required, right, for prediction of change in the voltage on the DC bus with reference to all these parameters. So now you can see that how we have to utilize the component based modeling together, right, for predicting in this case especially the voltage at the DC bus. Is it okay? So just I have given you one example, or maybe you can use this task for your research project also. Or maybe, like, if time permits, you can prepare maybe 1 or 2 page outline on this topic. What do you think, how we can maintain the voltage sustainability on this DC bus and why it is required and how it is going to vary and how you are going to predict it. Anyway, so we will move forward because this architecture is very close to my heart and I can speak on that, or I can teach you on maybe hours and hours, but we have the limited time. So compared to previous slides, what we have seen here, new change, that capturing the oxygen, storing it, utilizing it in the fuel cell and producing the required electrical energy during a particular time period till it reaches a certain amount of energy level at the DC bus, taking into account the variation or prediction of this renewables and the load also. And we have to consider, like, this is not a simulation work, it was a real experimental work in which the control system or algorithm what we discussed today and in the yesterday's lecture was implemented. Then next point which may come in your mind, if suppose nature is not favoring us and we want to have testing of this system as a test bench, then how we are going to do that? Because sometimes nature may not favor us, we don't have the wind, we don't have the solar photovoltaic. So to overcome that, here you can see that programmable power source have been used. So this programmable power source is very important. In this programmable power source, based on taking into account the available energy resources at a particular location, we can do the prediction that one, and based on that prediction we can do some programming here in the programmable power source, and in place of wind turbine and the photovoltaic we can operate this system by using any type of intermittent supply which let's say we have predicted for a particular location. So that we can do, and then we can test the operation of such type of system. Same time here also we can use the programmable load for testing this operation of such type of system under the different dynamic conditions also. Is it okay? So I believe that you might have got some learning, right, about the operation of integrated renewable energy system with focus on hydrogen as an energy carrier. And why we have to focus on the hydrogen as an energy carrier? We have seen that hydrogen economy document. It says that by 2050 we may replace our fossil fuel based economy or making it more decarbonized. Then we have to use the hydrogen. And now in media and everywhere you might have noticed that all these leading industrialists, they are starting the big plants for producing the hydrogen. Not only in India but all over the world. And of course the geopolitics also plays a major role on that one. Is it okay? Now move forward. This slide is going to provide you the specific component of the system which we discussed. Like wind turbine, it was of 10 kilowatt, 3-phase permanent magnet, synchronous generator. Photovoltaic array, it was small capacity 1 watt peak, 1 kilowatt peak. Electrolyzer, it was 5 kilowatt alkaline. And to connect the electrolyzer to the DC bus, buck converter having the peak capacity of the 5 kilowatt. Electrolyzer alkaline operating at atmospheric pressure including compressor. Similarly, fuel cell, proton exchange membrane fuel cell, 5 kilowatt capacity, manufactured by Ballard. To integrate that, boost converter, okay, PWM switching signals, capacity 5 kilowatt. Fuel cell operating voltage was 24, DC bus voltage was 48. So we had to design that boost converter based on that range, 5 kilowatt. So you see how your electronic engineering is also going to be used for that purpose also. And then of course we need programmable load also to test such type of system under dynamics of the load also, and of course programmable power source also. And to maintain the voltage or short-term energy storage, we may need battery bank on the DC bus also. And then DC source which I already mentioned, and storing the hydrogen and oxygen also. So those were the specification of this system, and maybe you can use this specification for your further research work. Let's say if you want to develop control systems in which you want to use some machine learning techniques or with the prediction that how much hydrogen is going to be produced and how the energy level at the DC bus is going to be changed, how the voltage sustainability at the DC bus is going to be changed with more specific examples. Okay. Now here you can see that what I am talking, it is like a real system, is not? So here this is a 5 kilowatt electrolyzer, 5 kilowatt fuel cell. Okay. So this all it comes that under the sustainable technology here, and now here you can see that big cable here. This big cable is for the wind turbine, small cable is for the photovoltaic because its capacity was small. This is 5 kilowatt fuel cell, 5 kilowatt electrolyzer. This computer, we treat it as a master controller where we implemented all the algorithm. This computer, like let's say the microcontroller, in which all the algorithms what we discussed systematically have programmed here to control the operation of the electrolyzer. Similarly here for the fuel cell microcontroller, this computer it works for controlling the fuel cell operation, and here it was a compressed air in the first stage, and hydrogen which as a fuel because it should not be within the lab, it was outside of the lab. Okay, because we have to take into account health and safety conditions into account. Then in this master controller there is a lot of information coming from hydrogen detector sensors also. If suppose there is any leakage and like that, so then this hydrogen detectors can stop the operation to main controller or shut down the plant basically. And then of course the electrical fixtures or electrical installations within such type of lab should be flame proof, not like having any spark or anything, otherwise there may be risk, fire risk, because we never know, and health and safety should be on top priority. And on top of that, if suppose we never know if nature if we have some fault and like that, then the complete roof of the lab is to get open. So it means the hydrogen will go immediately to the atmosphere. Okay, because if we do some combustion analysis of the hydrogen using some CFD modeling and like that, so one can see that hydrogen flame goes straight up, not like this. Okay, so that also a very good part, like because for CFD analysis also we need some good computing engineering background also. Okay, so that is also very interesting. So now here you can see that how the system different components they have been integrated together with different domain knowledge. Then of course this power electronics or electronics is very important, right? So these are the DC-DC converters. These DC-DC converters are used to connect, right, between the fuel cell and the electrolyzer also, between the DC bus electrolyzer and fuel cell to DC bus. Okay, so those what I have shown you. Now we will come to the results, because you are more interested now on the results of the data, let's say. Now these are the available data from this system. And under this intermittent data set, how such type of system are going to work. Because now what I believe that your objective is like to get more understanding about machine learning, and for machine learning you need the data, and for that you need some specific cases also. So here the specific cases are sustainable technology, let's say. So now here you can see, or this is for one particular typical day operation. On this particular typical day operation, let's say it started at 9 o'clock in morning, for example, until 5 o'clock. During this whole day, you can see that how the variation of renewable sources are there. So it is quite intermittent. Now, using some prediction techniques, one can predict maybe 10 minutes ahead or 15 minutes ahead prediction of this wind and PV also. But here I am just giving you the real operational data. when we have this real operational intermittent data and or input, let's say, when that input is given to the system which I described, and in that we have so many different components which you have seen now. You can see our objective was hydrogen production. Then of course when we have the deficit, we have to do the hydrogen consumption also. So here you can see that this is giving us the hydrogen. Now based on the previous values, what we have seen on the previous slide, these are the real, but you can use this data on doing the prediction of the hydrogen which we are going to be required, and that prediction of the hydrogen production, let's say, is going to be very useful for making the planning to the main controller also, how we have to operate the electrolyzer, fuel cell, how the energy level at the DC bus is going to be changed, so on and so forth, and how, not only that, how much the energy consumption is going to be there by the electrolyzer also. So here with reference to the hydrogen production, you can see that how the electrolyzer input power is also there, and you can see that renewable power, it is a combined between both wind and photovoltaic. That's how it will do. Okay, so you got the idea now here how such type of systems are going to be operating under the intermittent conditions. Under these intermittent conditions, of course, load is also going to play the role. Here you can see the load fluctuations are also provided here. And one more thing which might have come in your mind, that hydrogen production should be continuous. Why there is transients or regular transients are there, right? It might have came to in your mind why the regular transients are there. So those regular transients are due to the compression, because the hydrogen flow meter was after the compression, and the compression is again consuming the energy at a particular interval when the buffer storage tank is full. So you see like how complicated it is going to be there. So it is not that easy for human operator to operate such type of system. We need to do then to have the autonomous operation. For that, our control algorithm, what we discussed earlier, should operate properly. Otherwise, the system is going to fail, and here you see how the intermittency are there. Then moving towards the next point, hydrogen consumption. Because we have seen that at some point, whenever there is a deficit from the primary renewable energy sources, okay, and then of course the energy level at the DC bus is going to be changing, and taking into account all these factors and the load dynamics also, we need to consume the energy which we stored in the form of electrolytic hydrogen, that is hydrogen consumption, for producing the fuel cell power output at the DC bus. Is it okay? Because you see both operations are there, and then when we are having such type of system in operation, we have to be very careful that there should not be simultaneous operation of electrolyzer and the. Is it okay? So now let's say if I give you a task, that if you have to develop control algorithm based on prediction of the load, based on prediction of the renewables by maintaining the voltage sustainability at the DC bus with maximizing hydrogen production, but at the same time making the reliability of the load also, because that is also our output. How you will develop a control algorithm for that one, how your flow chart should be. Maybe that should be your task, and if you complete that task as an assignment, then we will take that assignment as your examination. Is it okay? Then maybe we can see that all of you participate in the assignment process. Because I have given you all the feedback. I have given you what it is going to be required and how we have to produce, how we have to proceed further. Okay, and now here when you will develop this algorithm, so let's say you will make the flow chart, because you cannot, it is difficult to include all the physics based equations in the model, but let's say you will put as a block diagram there. Okay, and of course then we can take the expertise or knowledge from the domain experts also, setting those models and like that. So here you have to see, here I have given you the results for a one-day operation, but we have to run this system continuously. Okay, so this continuous operation and making the planning, we need to have some prediction, and that prediction is going to help us to whom? To the master controller in making the decisions or making a plan. Okay, and then based on that we will get the idea that how much hydrogen has been produced and how hydrogen is going to be consumed. So I think this is a very interesting topic, and you can take your time, maybe during evening time or like that. Please try to make a good assignment on this topic. So that will be really interesting for me also to see that how the participants, they are learning and what thoughts are there in their mind also. Because I may be thinking from my perspective, but you may have the different thoughts or different approach from your mindset or maybe from your background point of view also. Yes, you are saying something. No? Okay. Is it okay? So there are a lot of things, like here you can see that how the utilization factor, energy efficiency, all these factors, then of course we need to calculate. Numbers are also important for us. Okay, so those numbers all we did and like that. So there are a lot of things which I can discuss on this project, and the results from this project are highly recognized. They have been published widely, not only in the IEEE transactions, but in the IEEE societies also, including International Energy Agency also. And it has the work which this one was done, highly cited. Okay? And I'm quite pleased that some of the work which me and my team did, let's say 25 years before, is going to be very useful for this hydrogen economy. And now Indian government is also planning, and every state they are making their plans to have more and more green hydrogen production due to geopolitical situation, or maybe commitment to the sustainable development goals, or commitment towards the net zero, or whatever there is. Okay, so this topic is quite interesting, and I request you, if time permits, please prepare one algorithm, and maybe you can carry such type of the work in cooperation with your students or your scholars also, if they have the interest on this topic, and I will be very happy to provide you further feedback on this topic, in which you can intelligently integrate machine learning techniques also. Very good. So shall we stop now? Good, thank you. Now we can have good lunch. always we have a limited time. Okay. Taking into account the external impact, share, because we have limited time and I also get tired, but I will share those research articles with you, and then when you have the free time, you can go through them also.
Polynomial regression, logistic regression. Okay, the same way classification, that means you have only binary output, two outputs, one is positive, yes or no, positive or negative. In that case, you may be able to classify as SVM, one line will be created, one line will be positive, one line will be negative. We are separating the data, this line positive data, this line negative data, maximum margin needs to be considered. Or we are going to create a tree. That means there is a parent will be there, child will be there, child will have sub-child will be there. So we can choose the path, which decision. So by one decision, by another decision, we are able to classify. That is gentry classifier. And in simple learning is we will take multiple classifier, and in that case some classifier will provide weak result, some classifier strong result. So we are assembling multiple classifier, and then we are able to improve the accuracy, like boosting technique, bagging technique, many techniques. So I can start now related to Python will be the language. Okay, I'll take very short, okay, because we have very limited time. So you have to cover entire part. In that, I believe you are familiar with Python. Okay, in Python there is a general purpose high level programming language, and it's connected with all other languages. Whatever the languages we have used like C, C++. So ultimately we are familiar with language, that we can utilize Python in easy way, because all components we learn from basic languages we are going to inherit. Ultimately C will have procedure oriented language and C++ is object oriented language. So both components will be utilized here. We can write a program. In C we can use for loop, while loop, or particularly if else conditions, or multiple component will be there. And C data structure is important. So we have data structure. Data structure means we have collection of data. So collection of data, here we can say particularly list. So we have to create the list set, or we may have dictionary. Dictionary means pair value will be there, key value will be there. So that is the ordered collection of data or unordered collection of data, or structured data is organized in structured way. So we can do various other concepts like a file handling. We need to open the file, close the file, read the file, write the file. Likewise, we have condition. We have if the condition will true, else, multiple else, or else if. Likewise, mechanism will be utilized for decision making. For looping, looping is required for repetition tasks. So you can use for loop. If you have unknown how much time the loop will work, so you can use while loop. These are the two loops are there. Conceptually same concept we are going to utilize here also. So you should not go to learn the language. Just directly you should remember you are familiar with languages, then you can use it. So our concern widely used among the developer community. Most of the community nowadays replacing to the either MATLAB they are using, or either they are using this language. So Python, already I said, general purpose language, that means can use for multiple applications. General purpose means anyone can use, like data science, like script, like machine learning, like desktop application, website development, many tasks we can do. High level languages means human understandable language. That means with strong abstraction from details of the computer. So related to Python, we can just observe that Python versions came. We have seen various versions came in the market from the past 20 years. So we started from Python 1 version from 1994, then 2, then 3, then 3.11.4. Recently, that is June 2020. So Python does not support backward compatibility. As the feature 3.0 are not available in Python 2.0. So three versions will not support the backward condition. That is the main problem. Library will be updated. That means you have to change the complete coding. That is the main problem because library updations are not back propagated with the other cases. So already Python has many reasons. Why it is popular? Because demand a few reasons. Emphasis on code readability. You can see that if you want to write a code in C, how you write a code? You have to write a library, studio.h, then void main, then bracket start, then integer AB, then print value, then scan value, then close the bracket and return 0. Likewise, the code will be there. And if you want to print hello world, you should write this code. So in the bracket, your code will be there. Now in the Python, directly print hello world. Then hello world will be printed. So a single statement. And this will be work under the compiler level and but interpreter. Python will support to interpreter. Line by line, statement with statement, we can run the code. I think you all aware about that. So here it's a code readability, shorter code, easy writing. So programmer can express logical concept. In Python, fewer lines of code will be available as compared to other languages like C++, Java. But in C++, you are using classes that you can use same here. You are using operator overloading that you can use here. You are using polymorphism, then you can use here. You want to use inheritance, you can use. Inheritance means the object which is already clear another class, and you want to use another class. So you can inherit that attributes in another class. So likewise, OOPS concepts will be utilized here. Similarly, Python supports multiple programming paradigms. Object-oriented, as I already said, interpretive function programming, and it provides the extensive support library and dynamically typed language. Okay, so this is the type based on value assigned. These are the certain features you can observe from here. So the core of philosophy for Python is summarized. That means the gen of Python, Python 20, which include these are the characteristics. That means beautiful is the better than ugly, implicit is the better than implicit, simpler is better than complex. So like readability count. So these are the certain introduction point of view we can understand. So simplicity is our requirement. Python is interpreted. Interpreted, I said, it's a line by line, statement by statement interpreted language. So the code will be directly converted to executable file through Python. But in terms of C, C++, it will convert into, that means bytecode. Then finally it will convert to execute. Two-stage conversion will be there. Compiler will compile entire code. Then finally complete compilation will just execute and the code will become error-free. Then you are able to run the code. But interpreted line by line, you can easily directly run the program from the source code. Python convert the source code into intermediate called bytecode. That which then translated into native language. No need to worry about linking and loading with libraries. So that was the problem when we were using other programming language during that time, C++ or Java, linking and loading the library and then finally locating the library in particular memories. That was there in earlier language. But here directly we can utilize and dynamically type. So do not need to specify the type of variable. That means we should understand about in languages, all are familiar with data types. You have data types, integer, character, float, all are data types. So we do not need to worry about the type of variable. It has simplicity. They decided what type of value in there and how the value can be assigned at a runtime condition. So next, so related to simplicity, that C, Java, if you write the code, that means relate to this public class hello world, static void, then system.out println. This is the statement we are doing. Here simple print hello. Very simple. So this is the way we can learn about next. These are the scalability. Python support to scalability, that scales very fast, and as well as all languages which we are using like .NET, like other languages, C#. So Python is a leader in scaling. That means Python has more and more possibility. Saying that Python supports will provide the, even if you are having known Python programmers who knows only C++ design. So Python will be better than in terms of time needed to develop, verify the code, corrections also. We can do very fast corrections. So it happens fast because you do not spend your time for find memory leaks or work for compilations or segmentation faults. These are not required here in this case. So the next, libraries and frameworks is very easy. So due to the popularity, Python has hundred of different libraries. So many libraries has created from the past 10 years, and frameworks also very great addition that we have developed for a developer purpose. So lots of manual time we can say easily replace the whole solution. So particularly a geoscientist will find the many of this library will be focused on data visualization, data analytics and machine learning. That means if you are working under that domain, they can utilize all many libraries, particularly for data visualization. That means we can utilize the data, visualize the data, like you are using in MATLAB plot statement, subplot statement. So by matplot library you can use it. Likewise you are using array handling or many other data type handling, you can use pandas library. So likewise various data libraries are available that we can utilize, like for application of image processing. We were using in MATLAB IMRead, IMShow, many commands. Now here also we can utilize with the help of OpenCV, CV2. That is available. And with respect to data analytics also we can develop with respect to machine learning also. So libraries and frameworks, that is the more important part here. Huge community. There are many people are working in that domain. If you find Stack Overflow, if you are facing any error, you type the error, you may get many helps through internet. But in other programming cases, you have to solve your own problem. But here community is very strong. That is the main important part. Powerful community is there. And you might think that should not be one of the main reasons. You need to select the Python, but truth is vice versa. So if you don't get support from other specialists, your learning path can be difficult. That is the main important, because if you are facing a problem while writing a program, then it will be difficult to manage. So that's why you should know that this won't happen when we are using Python. That is the main important task. So according to that, application areas, we have software development, we have data science and visualization, I said, we have web scraping, we have desktop GUI development. We are using GUI on desktop. That has developed, website development, and YouTube, they are using sharing of video. Through Python they develop. So many companies like particularly Google or particularly YouTube or IBM, they all are using our website development, internet scripting. All these kind of applications we are using through Python. So Python supports are huge. That means website development and machine learning and AI algorithm implementation. So as of now, we have seen Python is scalable. It's particularly it's a very popular because of the huge libraries are available, because of the various frameworks are available, and because of the huge community are working in that domain. That is the main important part. And various applications, as we can see here, so we can start getting started. So finding an interpreter. That I said we are going to use IDE. Everybody know about IDE. You are using languages, so you must aware about IDE. IDE means Integrated Development Environment. Like you are using code block or Visual Studio. That is, we can say as an IDE. So IDE is our requirement. So there are many interpreters available. That is purely from Run the Python. So related that can be bundled with Python software. Python packages are there, we can download that by python.org. So online interpreter like we can use for Geekforge, geek.org, that can be used Python program, Anaconda. So we are working Anaconda Navigator, under the Anaconda Jupyter Notebook we can install. Now one more advantage, Anaconda Navigator if you are utilizing, like you need not worry about your workstation, your computer, directly you can use Google account. So Google Collaboratory, Google is providing server with online mode. Okay, that means you need not require to install the complete software. Directly just log in Google Colab, and in Google Colab there is a notebook is there. In notebook, line by line you can write the code. And library also you need not worry, directly install libraries are there. In runtime also you can use GPU, you can use TPU. So almost you all are familiar with that. That means directly we can start the program, we can run the program, and we can buy very cost effective. That means 1 month 1000, and we can utilize. And but if data is increasing, that is the one currency. Another, memory. Memory means you should have more memory in your Google Drive. Google Drive need to store, so you should have 15 GB normally. But normal companies, industries, they are providing, or institute are providing, like government institutes, they are providing us more than 200 GB. That means we can do the research. But private, you have to buy. But we can buy the memory also. That is also not that much costly. If you are doing research, you want to store 1 terabyte, 2 terabyte, you have to buy them. So likewise, Anaconda, so distribution is Python and R programming for scientific computing, and aim is to package management and development. So related to, we can start, that means like just type in following code. That is a start of the interpreter. So print hello world. So you can write the print hello world. But if you are going to write a program in C, what you have to write? Studio.h, quantity.h, iostream.h, many libraries you have to integrate. And then compiler will compile entire program. If any error will be there, if you are able to trace, okay. If you are not able to trace, search it. So once your program, but there are many bugs will be there. There are many problems will come, like a garbage data collector or dynamic memory management. That means we need to declare any array. So we have to declare with respect to perfect data structure. Like in data structure, what we have studied, malloc. By that way, we have just start the memory and that free the memory. Like that, dynamic memory allocation we will utilize. And dynamic memory allocation is very important with respect to data collections. Data will not become a garbage to the system. So that is the main important while design of embedded system, embedded application. Okay. So here we have learned linked list, we have learned stack, we have learned particular binary tree, AVL tree, many things, non-linear data structure, linear data structures, all we can utilize with respect to Python. Okay, depend on your applications. So ultimately Python comments, single line comments. That means just like a simple statement we can utilize. Single line comments start with the hashtag, that means symbol with no white space. This is the comment. Yeah, this would be a multi-line. So Python is that several lines like that. So comment, there are useful information. The developers provide the maker and reader to understand the source code. Like in normal programming, where whenever you are writing a program in assembly for microcontroller, microprocessor, the right hand side we are writing a statements, like that is called comment. So comment, by that way we can understand what is the meaning of that command. So built-in types. So there are various kind of informations that computer can process, like numbers, characters. As I said, data types. So data type is also very important while writing a program, either in C, either in C++, or there are many programming languages are there. If you are EC, you are using Verilog, VHDL. Okay, like people are using TCL for creation of ad hoc network, communication network. So various languages will be there. So Python and R languages, which are very popular, that is the kind of information language will be able to handle, that knows of type. So many common types built-in Python will be there, like integer, floating point number, strings. Mainly these are the data type we are using. So according to that, integers, like integer type, whose numbers such as like 1511350 or -35, 1.5, not an integer, because it's work as a decimal point. But 1.5 you have to declare as a float. Next. So floating point number. So like that, floating point number are decimal point with exponent. Like both will be there. 5.0, 10.24, 0.0, 12, like that. So this is another data type. Next. So related to another string. String is a sequence of characters. That means string is a Python surrounded by single quotation marks or double quotation marks, like that. Print hello world hello world. Both are the strings we can declare. So many type of information that compiler can process, like numbers, characters in Python. This kind of informations are there. Like variable. So variable is a label and locator memory. A equal to 20. So A with 20 will store in A. That is called variable. So we have the variable that is located in memory that can be used to hold a value. That means we need to store the value. Where result will be stored, like example, you have entered A equal to 2, B equal to 3. We want to add two numbers. So C equal to A plus B. So C is the variable that will hold the value. So like here also we are using, this is the how we create the variable that is called count. As I said, total number, which contain the integer value of 0. Next. So likewise we have if definitions count 0, we have declared count, we store the 0, we define count equal to 2. So variable is a label for location in memory. So it may only contain letter, uppercase, lowercase numbers. It may not start with number, it may not be key. So that is the purpose we are using this. Now operators. So we are having many operators, arithmetic operator, logical operator. So many operators are there. Operators are the main building block of operation in the languages. So operator allow the programmer to perform different kind of operations on operands. So it may be same in terms of C, in terms of C++, or it may be MATLAB, or it may be Java, or it may be Verilog, VHDL, many languages we are using. So operator would be the same techniques we are using to just like a operate the data, operate, so arithmetic operators, these are the operations are there, like addition, subtraction, multiplication, division, all these are the operation we can do with the help of operator. So arithmetic operator, operator precedence also will be there, we are using with respect to how the procedure will take place. So bracket will be there or without bracket will be there. If bracket will be there, the calculation will be different, but if bracket is not there, it will be precedence by like that. Then multiply, then division, then this percentage, then plus and then minus. This is the priority is there. If you are not using bracket, so that already you are aware about that. Then relation operator. So that is equal to, not equal to, greater than, less than. These are the relation operator we are using. It returns the true or false according to the conditions. Now logical operator. So you know very well logical operations, and, or, not, XOR. All these are the operations we can do with the operator. Okay, so these are already aware conditions. Everybody knew about that. Okay, so basic data input. So in C, what we are doing? Integer, we are entering the value. Integer will be declared. Float will be declared. Then we are inserting the input. So we have to ask the input from user. Input will be the user input, and the output will be generated by a computer. That means result will be presented on the screen console anywhere. So likewise we have the input, we have to just say take the input from the user and evaluate. So like input, enter your name. So you will enter your name, they will ask. So likewise many GUI you are using. There you are writing a, like you are writing, you are filling a form for any exam. So what they are asking? Enter your name. So it will go as a character. They are asking your age, that will go in number. They will ask some other value, that will go in float. So likewise float data type, or integer data type, or like character data type, or like string. So sometimes name is a string. Okay, so likewise data type will be utilized and input will be identified. Then Python indentions will be there, selections. So selection is a Python made by using of two keywords. So how we are going to select? Like you want to design a one program that means 260 students, you want to create a results. So you can say if the person having 60% first class, then 60 to 50 second class, then less than 60 third class. So likewise condition will be there, so that selection is Python. So selection is not a common, it's not a different thing, it's a common for all languages. So if you write the program in Verilog, if you write the program in MATLAB also, you can use if A equal to this value, then output, or all other value will go else, or you may have multiple condition, if, else if, then else. So likewise this condition, so like if mark is greater than 80, grade is A, that is CGPA, based then 65, grade B, then 58, grade C, grade D, likewise grade B to print it. Result can be printed. So like this is the fundamentals of Python. The two kinds if, else if we can use, others are we can use. Now syntax and data structure. As I said already, Python support all variables and data types. Python supports control flow. Control flow like if, else, loops, for loop, while loop, and functions. So you can write a function. So in C you have written function. In C++ you can call that functions. Multiple times that function can be utilized. So Python also will support functions. Functions are reusable block that is available in terms of code. Like MATLAB, what they are doing? IMRead. IMRead is not a command. It is a function. We are calling IMRead, then IMRead a complete one code. It has written initially by 2009. Now by MATLAB IMRead 8.jpg. It may read entire image and show the image. I am show. I am write. Okay. So likewise, that is you are thinking like a command, but MATLAB what they are doing? They are converting all programs in terms of one function, so that they are reducing the complexity for user. So likewise, MATLAB has developed the GUI for machine learning. What GUI you are doing? You are just taking the Excel sheet, you are calculating the features, you are applying a machine learning classifier, and you are generating the classifier report, and you are getting the all parameters. Like the last class we have seen true, positive, true, negative, false, positive, false, negative. So all this can be just code. So it's a reusable codes that perform the specific task that is defining as a function. So these are the syntax and data structure. Now setting up your Python environment. Use Anaconda distributions. Environment must be created virtually, and you can start the project through Jupyter Notebook. So Jupyter Notebook will provide the interactive coding environment that you are going to start with coding environment. So Anaconda is a freemium open source distribution that is support for Python and R programming language that we are using. So that language particularly for large scale data processing, predictive analytics and scientific computing. Aim of the Anaconda is simplify package management, deployment of various packages versions that manage. So overall 4.5 million users are there. They are using Anaconda distributions, Python data science and machine learning. It includes 100 of popular data science packages, Conda packages, and more virtual environment for Windows operating system, Linux operating system. So it does not depend on one operating system. We can use, so Conda makes we can easy to install, easily we can run, easily we can upgrade, and complex data science and machine learning library that also can be utilized. So related to how it is different from Python, that means overall Anaconda data science libraries are there, 1000 Anaconda curated community data science packages are there, and we have developed the data science project by using a various IDE. It supports Jupyter, it supports Jupyter Lab, it supports PyTar, RS Studio. So we can analyze the data, we can see the data, visualize the data. We can perform with respect to these libraries. NumPy is there, Pandas is there, NumPy is there. We can visualize the data with Bouquet and data shader or various matplot library. But that means we can see the plot, we can visualize the plot. Finally, we can create the machine learning, deep learning models also by scikit-learn library, TensorFlow and H20 or TAN. These are the frameworks or APIs are available. Now we have to install the Anaconda with respect to particular Python versions, Python 3.6, any version, and with respect to operating system also we can install. Once installed, after the installation the process will be Conda repository will be there. It will support to Anaconda repository, support to cloud, support to enterprise, support to Conda Forge. This community will be there. Like Anaconda will install, this navigator window will come. So you have to launch the Jupyter Notebook. You can launch the Spider. You can launch anything. So we can use now notebook, Jupyter Notebook. So once Jupyter Notebook will come, just you have to install the various packages. So pip and Conda installer will be there. Pip is a package management system used to install the management of many packages through pip command. Python 2.7 later versions they are using Python 2 series. Python 3. version later version use pip 3. So likewise we have to install by various packages and libraries. Like that, these are the commands are there. Pip list outdated clip search. So these are the packages you can see. We install package, install the package more than that, environment and package version, package uninstall or package upgrade. All these statements can be utilized. We can create the virtual environment, and then we have to write a program like that. First we have to create the environment, then we have to activate the environment name, then install the Jupyter, Honda install Jupyter. This command need to work. Honda install C, Keras TensorFlow. So one will be the front, that means front end, another will be back end. So we have to utilize Keras and TensorFlow. So that will be Keras is API. Honda install OpenCV library for support of image processing library. Honda install matplot library, support of plots in other words, and TensorFlow with respect to GPU. That is the version will be there. Now machine learning already we have done. Yeah. So whatever the way we have utilized, what is the benefits when we are going to see the machine learning? Powerful processing, better decision making, quicker processing, accurate, affordable data management, inexpensive, analyze the complex big data. That is the main concern. So whatever the steps we are going to apply here, first we will see the problem statement. First you have to decide the what kind of problem you are doing. So related to problem statement, you have to define the problem. Then we need to talk about preparing the data. You have to collect the data. Already data has been collected from various sensors, various sources. Should be there in organized form or appropriate format. Or if it is not there, you have to organize them or prepare them. So preparation. After that, evaluate algorithms. Various algorithms as per the data characteristics. What kind of data you have collected. Then improve the result. Then present the result. So that is the steps is going to apply. So already we have seen traditionally what we were doing earlier days. You all are programmer from your BTech onwards, from first year onwards. We all are programmer. We are using programming from first year onwards. So we were using the traditional methods. When I studied during that time, there was no machine learning. I was doing the programming with C, Visual Basics, Java, or till .NET we have learned. But after that, we are VC people, we have learned other languages also, very long VHDL. So that are languages over there. Then we have entered into MTech Masters, we learn some other languages, depend on the projects, or depend on the research, dissertation. Then when we started to research in terms of PhD, then we started to know various languages like Python became popular because of that reason. But nowadays it became popular towards the graduation levels. That is why machine learning also became popular. But machine learning does not require an academic level. That is only for computational level. If you are doing some project, if you are doing some hardware capability work, then you can use it. So here concern is computation work you are doing from the long back. Okay, from the past 40 years, we are using that thing. But what about machine learning? Data, result, then computation will be there, generative programming. So you are producing the result by traditional programming, but here you are producing the program. That program is like a one program in your brain is there. You know you have seen something, so you can recognize. So like you have seen the Taj Mahal, so you can recognize. Someone has not seen the Taj Mahal, so will it is recognized? No, you cannot recognize. So you are aware about that, so that means you can recognize. You can say that is Eiffel Tower, that is a Pisa Tower, that is the like different towers are there, Qutub Minar or whatever you have seen. But something you have not seen, not trained by your brain, you cannot recognize. So ultimately one program need to be written for machine learning. That is the computational process. Based on the data and the result, you are designing a program. That is the difference between these traditional methods versus machine learning. So these are the work we are doing with machine learning: classification, categorizations, clustering, trained analysis, or various anomaly detections, visualizations, and finally decision making. So these are the representation. We can create a decision tree, we can create a rules, we can create a logic, we can write a instances, graphical models, neural networks, support vector machines, or model will be ensemble. Ensemble means multiple algorithm parallelly will work. So some method will be very strong for some kind of data, some method will be strong for some other kind of data. So you can combine all methods and you can identify the votes. So which method has given highest voting will be calculated. Based on that, the result will be evaluated in terms of classification, in terms of like decision making or other aspects or predictive analytics. All these cases will be there. Evaluation, already discussed in the first lecture, evaluation will be carried out by various performance measures. Performance measures means accuracy, precision, recall, square error, mean square error, okay, PSNR, peak signal noise ratio, or posterior probability, or cost, or margin, or entropy, or divergence. Many parameters are there. Depend on data. Which kind of data you are having, or which kind of applications you are performing. Based on that, performance measures will vary. So optimizations is our concern. That means you have to apply the many optimization methods, like a genetic algorithm you have, linear programming you have studied. So likewise, like greedy search method is there for combinatorial optimization, convex optimization, gradient descent method will be there. So you all are aware about neural network. Neural network is resemble with brain. So whenever you are thinking your brain having neurons, some weight will be there. Likewise, whenever you are designing a neural network, weight will be there. How to decide the weight? So weight will be decided by optimizations. That means you are just thinking on pressure on the weight. So particular weight will be optimized by the gradient descent method in artificial neural network. And what is exactly procedure we are learning? So we have the output and we are predicting the output and we are matching. That is called error. If your error will reduce, that is called loss is going to reduce and accuracy is going to improve. So our ultimate goal is reduce the loss and increase the accuracy. So loss is going to increase by more number of times of learning, more number of iteration to learn different kind of object with their features. So by one weight we learn one feature, by another weight we learn another feature. So likewise multiple weights will responsible to learn different features. And finally this feature will be added to classifier. Classifier will say as an apple as an apple, banana as a banana, cat as a cat, dog as a dog. So classification result will come finally. So here also gradient descent method is perfectly responsible to reduce the error by changing of weight. So error will be computed with respect to weight, delta E by delta W, and approach to 0. That will be given by optimizer gradient descent method. So likewise many optimizers are there. RMS prop is there, or ADAM will be there. Many other optimizer depend on what kind of data you are using, what kind of algorithm you are using. So likewise constraint optimization like linear programming everybody has studied. They are it is very popular. Because linear programming requires some objective functions are there. Based on the objective functions, you are solving the problem. You are finding the final outcome. So these are the optimizers available. The features of machine learning. That means so already we have classified the algorithms. Training data include desired output. Training data does not include desired output. Training data includes few desired output, that is semi, and reward will be given based on the actions. These are the types of learning. So this is the case. We have images of 100 written numbers. We are going to generate the machine learning algorithm and we are going to identify 1, 2, 3, 4. We are going having emails. We are having generating machine learning algorithm, generic. We are finding which mail will be going to the spam, which mail will not be going to spam, which will go to the inbox. So based on that we are going to classify. So these algorithms will identify based on their features. So libraries, these are the libraries. NumPy used for the n-dimensional array, Pandas used for data analysis library, Matplot for a two-dimensional plotting library, particularly for creating graphs and plots, Scikit library is required for algorithms for data analysis and data mining, and Seaborn data visualization library based on the Matplot library. So various libraries will be there. NumPy, numerical computing is a version popular Python library will support to numbers. SciPy library, very popular library. In this is the original image, this is the other different image, resize image. So this is the library which use machine learning algorithms. It contains different models for optimization, linear algebra, integration, statistics. So SciPy is also very useful in image manipulation. When you want to use image manipulation, this library will be utilized. So top of the basis is the matplot library. So in MATLAB what you are using? Plot A, B. You want to plot two plot in a single plot. So you are using subplot. Subplot will create 2, 2, 1. 2, 2 cross 2 matrix 1. 2, 2, 2. 2, 2, 2. So second number. 2, 2, 3. Third number. 2, 2, 4. So like 4 images. If you are having 3 cross 3, 9 images. So 3, 3, 1. 3, 3, 2. 3, 3, 3. 3, 3, 4. 3, 3, 5. 3, 3, 6. 7, 8, 9. 9 images will come. So you want 16 images in one plot? 4, 4, 1. 4, 4, 2. 4, 4, 3. That is subplot. Same thing will be here by matplot. So you cannot avoid the other languages concept that will be inherited. Understand? So subplot means you want to plot 2 in. So 4 plots will come. But if you want to separate plot, plot A, plot B, plot C, plot D, like single plots will come. So you may use single plot, all plots may come. Like precision, recall, all plots you want to bring and in papers you are printing. You are keeping in the paper publication. So you are not keeping separately. What you are doing? 4 plots. Copy and crop and paste. So area will save. So 4 plots will come in one area only. So likewise, matplot library will support for plot. So pandas library for data analytics, data frames, data cleaning, data analytics. This is the data will be available. We can utilize. So pandas are very popular Python library for data analysis. As you know that data set must be prepared before training. So likewise, we have created data in Excel sheet and we can read by .csv file. So it will be created like that. Quantity, capital, array, area and population. This 0, 1, 2, 3. This country, this is the capital, this is the area, this is the population. So we have to apply that pandas library. Then scikit library. Scikit is basically creating of multiple architecture in machine learning like SVM, logistic regression, decision tree DT or ensemble learning or random forest RF. These are the machine learning classifiers are there. We can use with this. Some are supervised, some are unsupervised, some are semi-supervised. We are using. So OpenCV. It's very popular from the past 10 years. Created by Intel. For particularly read a image, show the image. But earlier we were not using by C image reading and all. Once they have given this library, then we were able to use image processing through the OpenCV library. Otherwise we were using MATLAB. So with C and C++ we can use OpenCV, we can use image resize, image filter, image enhancement, all image processing libraries will work by OpenCV. So like that, these are the region of interest, these are RGB image, this is the drawing a rectangle, this is the rotating of image, these are the operations we can perform with the help of that language. Applying a machine learning to energy system. So what are the requirement energy systems are there? Demand forecasting. As yesterday we have discussed, predicting the future energy or energy resources. Which resources? Renewable. Either solar, either hydrogen or either other wind energy. So various energy will be predicted using historical data and weather information. So predictive maintenance. You have to maintain the system. So when this projector will fail, you have to predict. So if it is working, 10 years is over, then you should understand any time it may got failed. So failure maintenance will be there. Depend on that, it will identify the reliability. Reliability's component will be given to every device. So your phone you have purchased. So you believe how long you will work with your phone? 2 years, 3 years, maximum 3. You believe like that. You purchase television. So you believe my television will work 5, 6 years at least. You have purchased two-wheeler. So you believe it will work for 6 to 7 years. Okay, recently project 2025, you believe it will at least it will work for 31. So that is the main requirement you have to predict. Maintenance. energy optimization. But if you are buying a two-wheeler, what you are doing? Every 6 months you are going for servicing. Otherwise, it will not work. Understand? So, maintenance, energy optimization and grid management. So, we are providing the electricity, generating, transmission and delivery. So, how to optimize? So, improving the grid stability, efficiency through the real-time monitoring and control. So, why energy system matter? Because global demand and sustainability. So, as our concern, how we are employing the machine learning for sustainability. Sustainable energy solutions are very important for us. So, we have to mitigate the climate change impact and economically we have to rely on that. Okay, so we are not only rely because of only petrol will over or diesel will over or fossil fuels will over, we are also relying the cost also increasing. So that's why we started to utilize electrical vehicles nowadays. Criteria is we are worrying about how long will you have to utilize petrol, the cost also matter for some people. So reliably energy infrastructure derives the growth, it enhances the economical product. So production point of view also. So challenges in modern energy systems, these are the demand forecasting, grid stability and fault detection. So early fault detection is very important. By that way we can prevent outage, we can minimize the downtime. And demand forecasting, accurate forecasting is very complex and impacted by many variables. And we have to maintain the grid stability and integrating the renewable in one issue. So introductions to deep learning. So neural network at the core and neural network extended by deep neural network. We started use neural network. We utilize 2 layer, 3 layer. Then we have increased more layer, 5 layer, 6 layer, 10 layer, this 16 layer, this 19 layer, just next 50 layer. Likewise it became more complex. Structure became very complexity. So data-driven approach, deep learning needs larger data set and allow for accurate predictions. Similarly, we can use algorithms for pattern determination, pattern identification. These are the various key trends are there with respect to complex data and this provide the valuable insights. Deep learning for demand forecasting. So data collection, our first requirement, and model training. So during model training, if you are aware about that, there is hyperparameter, number of layers, number of filters with their kernels, max pooling, types of pooling, max pooling, average pooling or global pooling. Any poolings are there. Then what kind of optimizer you are using? SGD, RMS prop or some other hyperparameter would be there like activation function. ReLU, eReLU, eLU, many activation functions are there. So you have to decide. So that is training time you have to use. So data will be collected, model will be trained and real-time prediction. So we are going to implement by real-time forecasting based on the data and optimize the energy. We can distribute and minimize the waste. All these are the concerns with respect to and enhance the grid stability with deep learning. So real-time analysis, predictive maintenance or automated response. So system will provide whether this system has failed. So this system has failed. So automated, it will be analyzed that area some fault occurred. So fault will be recognized and response will be provided. So deep learning enhance the grid stability. If it will be self-healing will be there, self-fault tolerance will be there, self-predictive analytics will be there, automatically reliability, stability will increase. So real-time analysis for grid condition is main requirement. Predictive maintenance prevent the failure. Automated response will optimize the performance. So optimization of the performance is very important. Fault detections and diagnosis. As I said, sensory data will be collected from various sensors. So in an electrical plant, any plant will be there. Any sensor installed like a distillery plant or like a cement plant. So various sensors installed and continuous process is going on. We don't know which sensor failed during operation time. So we have to collect the sensory data and we have to anomaly detections and we have to provide the rapid response. So this area fault occurred provide the rapid response. So like deep learning will help to improve the fault detections, analyze the sensor data for anomalies, enable the rapid response for a potential issue, and it minimize the downtime and improve the efficiency. So various trends are there: renewable energy, distributed energy generations, energy storage technologies are there. So flexibility and emerging players like virtual power plants, electric vehicles, these are the new trends we are using nowadays. So emergence of new system with interesting control problems. So these are the trends over the last decades we are using. So control objective. Control objective is minimize the cost. So online control with respect to rule base. This is the heuristic technique. This is the neural network technique. This is the predictive control. This is the dynamic programming. So rule base will be solved by these two techniques. Optimization will solved by predictive control or dynamic programming. These are the two aspects we are using. So we can use with respect to multi-layer network and deep neural network. So which are having performance high. This is going to analyze later. But it's a offline support medium. It is also require formulations, and online computation cost is high. In this case low. Require predictions yes and no. But it can use for all. So related to this control, what we are using. Why deep neural network with other learning methods? Because huge variety of systems and applications are available with deep learning, and we don't know what are the features will be there. Could probably study a single instance of system and pick out the right features. So really possible that deep neural network and having to learn for control. Now training and evaluation setup. Generate the training data, train the model like a regression problem, and evaluate the performance like a control performance. Simulate the system using the neural network and we'll make the control decision. So suppose solve the linear programming offline to generate a data set. Regression problem will develop the model, and finally we are going to evaluate the control performance. So training data through linear programming. So neural network input, load, these are the input will be collected. PV generations, battery, state, or grid price, or PV predictions for the next, or load prediction for next hours. These are the network input will be there. Then we can generate the model. This is the fully connected network, and these are the hidden layer, and this is the output. What is output? Charging power is how much? Discharging power is how much? Power part will be there, and power sold. How much power has generated and how much power has stored. This is the network based on this input. That can be developed through the neural network. So neural network for regression problem, cost functions. As I said already, input will match with the correct output. So whatever the output will be there, predicted output will be there. In between you are computing, that is called error. So it may be mean square error. So square error, this is the predicted output and actual output. Y minus y, that is mean square error. So if it square error will reduce, that means you are approaching your exact result. So you must know neural network concept is what? Input multiply into weight, then weighted sum, then send to activation functions. Activation function threshold will provide the non-linearity and output. But what output? Result is already y and exact y. Y minus y, what is there? So you are having the ground truth. You are having exact result. That is the meaning of machine learning. What is the meaning of machine learning? So when you learn apple in the first class, you were not knowing apple as an apple. The teacher taught you apple as an apple, but after 10th standard, you know apple as an apple. Someone has shown you apple, you recognize this is apple. But when you learn first time apple in your childhood, somebody taught you alphabet A on the board. Then you learn A And finally you recognize and take exam also someone asks, write A. So you written A, but different way you written. Second standard you read, same thing you studied. Third standard same thing you studied. Likewise your brain has trained. So same procedure we are giving to machine. So we are showing A, just A must recognize, but A will be written by 1 crore people by different way or not. But in hospital you are going, or in bank you are going, you are giving your signature. 10 years ago your signature will be given and still you are giving a check to the bank. Bank is recognizing but that result is not 100%. It is 70%, 80%. But if it mismatch, what will be there? Bank will return your check. Return or not? Many times, because aging, your same signature will be there. Still same signature you are doing 10 years ago and now. Variation is there or not? But in the body, that is the mechanism. So machine also will deviate sometime. So confusion. So what way confusion we are giving in machine learning, deep learning? Augmentation. You know data augmentation. So we are showing the alphabet in reverse manner, rotate. And we are increasing the size of the alphabet by scaling. So likewise we are making or we are creating a confusion to the machine. Like I am observing just now. If you go to the code and I have seen the person from 10 feet far, code will not believe. They will observe first my eyesight. Because it may be possible, I may see you, I may not see you properly. But if you are in first this much distance, eyesight will be able to recognize. So they won't check my eyesight. So 10 feet and 1 feet, they won't rely your judgment. Won't rely your judgment. They may judge you with your eyesight first, whether you are healthy or not. If your eye is not healthy, they won't believe on your perception. Like machine also will confuse. If you are showing the object by like that, that is the procedure of augmentation. So we are adding the augmentation. That is the one approach in deep learning. I think everybody aware about data augmentation, data resizing, like that. So here also, ReLU is introducing the activation function. That is for non-linear. And finally, Y must be matched with Y by using of optimization. That means going back, change the weight. Going back, change the weight. Going back, change the weight. Who will do change the weight? Optimizer. Understand? So cost function will be the mean square error. Activation function on output, that is the calculation there. Evaluation performance, we are calculating the result of objective functions. That means we are simulating the system using neural network, make our control decision, adjust the control output to satisfy the customer. These are the visual inspection of neural network. Charging, optimal charge. Buying, optimal buying. Buying is different, optimal buying is different. So optimal condition, optimal discharging, optimal setting. That will be calculated by A. So hidden layer, mean square error loss. Training and testing, number of hidden layer. Mean square error, simulation with grid cost. Training, testing. See that number of training time loss is decreasing, but here is a and this is the number of, so 3 layers, 50 nodes, 10 inputs. This is your hyperparameter. And how the control neural network will be cost. So this is the loss and this is the simulation grid cost. So this is the wind farm optimization, smart grid management. So in the future, continue to tune their hyperparameter. That is our requirement when we are a developer of GIAN. 8 predictions for solar load as an input, 8 PV panel battery size as input, compare the other control algorithms, explore the way to integrate the real evaluation of neural network into training. So AI is widely used in the particular all renewable studies like PV, like wind, or like a combination for planning, for particularly construction, administration, prediction, regulation and transmission. It is necessary to develop AI software packages could help to recognize the electricity effectiveness and investment for individual and trades in coming. And particularly correction and optimization of renewable with electricity network utilizing AI will improve the flexibility, dependability and electricity consistency and profitability. That is the main burden scheduling. And AI has the potential to change the numerous power individuals or industries and boost development in upcoming years. That is the main concluding part of this part. Okay, so next part will just continue with a particular case study on this MATLAB as well as Python. Okay, so there is just 5 minutes break. We'll continue.
డ్రాప్ ఫ్రేమ్స్ పర్సంటేజ్ పెడితే నా ప్రాబ్లం అవుతుందా? హలో షాప్ డ్రాప్ ఫ్రేమ్స్ పర్సంటేజ్ పెరిగితే నా ప్రాబ్లం అవుతుందా? డ్రాప్ ఫ్రేమ్స్ పర్సంటేజ్ వస్తే నా ప్రాబ్లం అవుతుంది. ఏం కాదు, డ్రాప్ ఫ్రేమ్స్ పర్సంటేజ్ వస్తే ప్రాబ్లం అవుతుందా? హలో సిగ్నల్ లేదు అక్కడ. హలో హలో సిగ్నల్ కూడా ఉందా? సిగ్నల్ ఉందా? సిగ్నల్ లేదా? హలో వస్తా బ్రేక్ వచ్చింది. బ్రేక్ ఇది ప్రాపర్ చేంజ్ ఒకటి మనకు పర్సంటేజ్ పెరిగితే ప్రాబ్లం అవుతుంది. పెరగదు. ఓకే, జీరోలో ఉన్నది. అది ఏం కాదు, జీరో ఉన్నది. ఓకే, మరి ఇది అయిపోయినాక ఫోన్ చేస్తాం. ఇప్పుడైతే ఓకే వస్తాం. you are working, sir.
So we can continue now with respect to when we want to use machine learning with MATLAB. As I said, machine learning workflow would be like that means the workflow of access the explore the data. Data is available in database, but what is data? That is collected from various sensors. Okay, data will be collected from various sensors, but it may be converted either in form of values or either in form of images or either in form of signals. It may be anything. So signal, that is one dimension, or images may be two dimension, or value in terms of Excel sheet. Okay, so that will be collected, then working with messy data. So but data will be noisy, data will not be clean. So we have to do the pre-processing. Always remember, without pre-processing you cannot work in a data analysis or data visualization. So we have to first pre-process the data. So pre-processing technique, and then data will be very clumsy and huge. So what exactly we are going to do? We have to reduce the data. That is called dimension reduction. So dimension reduction technique as well as feature extraction. So we need to extract the features. Features may be low level, medium level, high level. So during the traditional methods, we were doing the feature extraction by using of feature extraction technique, and then we are feeding to the classifier. Now what we are doing the feature extraction by using of deep learning. That is feature learning. That is the automatic feature extraction technique. And then model will be created. Then optimize the parameter and model will be validated by creating of confusion models. So here desktop apps are there. We are using MATLAB, we are using C, C++, Java on embedded device and hardware are available. So this kind of package will be installed into the device, and device will work like a with respect to AI, automated diagnosis of the fault will be there. That means initially data will be collected, data will be pre-processed, that algorithm will be responsible to pre-process, classify and find out the faults and diagnose the faults automatically. That can be done in the particular car or anywhere or in an aeroplane or anywhere. So this is the complete desktop app application will be there. So what you are doing, you are creating a code like you have created an operating system. So operating system you don't have exact code. What you are having? EXE. You are having EXE. You have code of operating system. Operating system code not selling by the Microsoft. No one is selling operating system code. They are selling only EXE file. You are running EXE file. So you are purchasing a pen drive, you are purchasing a hard disk. In that software will be there. But software is auto run. During connection, code will run. During removal, code will run. That's all. That is driver. That is called driver. Device driver. So every device will run by the driver. Without driver, you cannot run any device. Either your camera, either your printer. If you connect printer without driver, can you run the printer? Printer driver will be required, otherwise device will not understand what is definition of the device. So device definition will be given to operating system by the driver. So that will be the final task we are doing. So AI is also doing like a product will be developed with AI. So AI will be the software. AI will be the software. That will just, whatever the task will be there, you want to optimize something, you want to fault regulations, identification, diagnosis, anything will be there. Let's example in medical field, data will be collected. How? By CT scan. Connected to the computer. That technician is asking, sit on the machine, taking the images by applying of radiation. And computer will be there, computer will capture the all images. But he is not giving immediate report to you. He is organizing, he is processing, he is completely generating the report. Then report will be written, what is the problem will be there in brain. Brain consists of Parkinson, Alzheimer, cancer, anything. That report will be analyzed by the particular feature will be extracted, classified and report has generated. Understand, it will be done by code. It will be done by algorithm. Technician is not doing anything. Just he is collecting data. So data collections, then working by pre-processing, then developer will develop the model and the finally integrate to the system. So ultimately, in terms of MATLAB, we are having classifier learner and regression learner. That is app will be there. If you see the app, That means this app will provide the tool for with respect to user-friendly environment for research and engineer, that they can use the any machine learning technique without any programming knowledge. You does not require to write a code also. Just only you can start with respect to select the data to the any file, and then choose the classifier, then train the classifier, access the classifier performance by report will be generated, and export the classifier. So that is the requirement in terms of this way. This way window will come, the data will be read, so select the data from there by this app, and you can test, you can learn, you can explain. These are the methods will be available, these are the blocks are available, scatter plot, confusion matrix, anything you want to generate, you can generate. So if this will be available, then you have to go through the procedure will be same. Similar classifier learner also, regression learner also will be work like a classifier. Same, select data, choose the regression model, train the model, access the model performance, and export the model. Like that. This is the model will be true false response and predicted response will be generated. This is the prediction by the various models. Now this is the data set will be available like .csv file. This will be available in workspace. Workspace is temporary memory given by Mac. This will be available here. This is the data sets in CSV file in terms of visualization. So data visualization. We have given a data visualization. By the library we are going to do this data visualization. This is the features. This is label. Now understood, label means with input you should provide the output. Like student receive 90% marks, so you are giving pass and fail. And you are predicting whether he pass or fail by program also you can. But how you will make that is pass and fail? You must know whether he passed by or not. He received 33 marks. So you know he is pass. And machine also will predict this is pass, P equal to 3. But machine has predicted fail. That false report. If it happened to you, what you will do? You go for recorrection. Machine has done this time. Happening or not? So machine can generate false report. Human are not generating false report. Machine is generating false. We are talking about machine only. So what is my point? So you have label. Student has appeared in the exam and they received the marks, and result has generated by user first and then given to the machine. Machine also generated, but machine may be predict correct or may be incorrect. That is called true positive or true negative. False positive and false negative. That is the role of AI. So here output must be available. That is called label data. Let's example, you want to recognize a car through the camera. So first you have to draw the car by your hand. And then that car and that car must match by your appearance. If you not draw the car, then how machine will understand what is the structure of car? It may be rectangle, it may be circle. So machine will learn circle as a car, but car architecture is not a circle, it's a rectangle. Rectangle and this line. So you have to draw exactly and make it, that is called ground truth or annotation in our definition. If you are a programmer, you should know this definition. Ground truth or annotation. If you are a engineer, you must know either electrical, mechanical, civil, but ground truth, anybody will tell you what is the meaning of ground truth. Exact output is called ground truth. That will be created by human or by software, by dedicated process. And output that will be created by algorithm, that is called predicted result. And predicted result will match by correct output. That procedure is doing AI. AI what is doing? Human error ko reduce. We want to reduce human error by program. We are creating a program and then we are generating the error. So this label and match with features. So alphabets, like you have the example tomato classification. So tomato will be classified by which feature? Color, first feature, and then pattern, then texture. Then you have two features. Either one feature is color, second feature is pattern, third feature is texture. Three features, and label is what? Tomato exactly must be available. Then what is the structure of tomato? Understood? So that label will be given, then input, then output. So black box means we have to write a program, then program must recognize tomato as a tomato. Got it my point? So same way we are going to design the output. This is the machine learning app. Various classifier will be available. You can use SVM, you can use DM, deep neural network, you can use neural network. So many classifier will be. Select data and develop the model. Then classifications. So generated the. So by default decision tree algorithm appear. We can select this algorithm. Data selected, algorithm selected. Then classification. Select all available algorithm. Run the training process. So you have to train the model. Then classification with the best accuracy. Select KNN algorithm. Then produce the result. Plot of various features. Confusion matrix will be plotted. So this is confusion matrix. So what is this? True positive. True positive. True positive. True. Rest is false positive, false negative, and true negative. This is receiver operating characters. And export the data to the code. Save the script. Then classes must receive the data set labeled to train. Now testing. Testing means unseen data. But in testing, no label. Testing means no label. Like exam, do you have answers also with the questions? Do you have seen that questions earlier? You are a BTech student, sir. So do you have the questions? You can understand very easily this thing. So in exam, whatever teacher taught, based on that experience, they are asking questions or not. That was unseen or not? That is the procedure, same for machine. Machine must recognize unseen problems. Based on the example, but question would be same like integration question. Question sin square x, evaluate. But you have studied already different cos square x. So sin square x will be same kind of cos square x or not? So already cos square x was taught in the class, but sin square x asked in the exam. Got it? Similar, the property will be similar or not? It does not mean they asked different thing which was not taught in the class. That is out of syllabus thing. With syllabus only we are asking. With features, learn. Whatever the feature you learn. The question is that we have made a classifier based on the tomato, but we cannot ask for potato classification. Because feature of potato will be different. Na? So potato classification won't work here. That is different thing. Understand? So likewise we have to test the model, prediction, classification, and bring the result. Then testing the classification algorithm. Different. These are the testing part. So we can see the result with regression analysis also. Because classification true and false only. Yes or no only, 1 and 0 only. But regression is continuous. Output is continuous. That would be also done. This is the select the data from workspace. Then started with the MATLAB. Then from the data set choose the independent dependent features. Then to examine the regression model where whatever the models are available. Then we have to show the plot. Then we have to check the plot with respect to model performance. And then we have to see the residual plot with respect to difference between actual and prediction entries during training observation. So we have predicted correctly or not, that will be done by this. So like same way we are using Jupyter notebook in 4 energy system. Jupyter notebook, how to use? Just see the Jupyter notebook. Just these are the notebook will do. Statistical modeling, data visualizations, numerical simulations, lab notebook, document sharing, process documentation, teaching, learning, and much more. We can use by as per the academic and industry point of view. Now, how does Jupyter notebook work? Browser, notebook server, and kernel. How this is user is working. So set up browser, run the same computer as server program connecting through the local web connection. Server retrieve the relevant notebook file communicate with the kernel to execute the written code and display the result in the browser. This is the files. When notebook will start in the browser, files running in cluster, this will be there. So files tab, notebook launches in the folders where Anaconda is stored, and limiting access of the file within the folder. Or to work with file outside the location, notebook must be started in different folders. And user can navigate the file system. That means you have to choose the file, where the file will be there, where you have saved the file. Like normal way you are using, you are clicking the file will open in the notebook. So likewise, user can navigate the file system, create the new folder, text file will be there, upload the files, use the standard drag and drop functionality that you are using normally, and then that would be there in particular operating system. So likewise, this is a new menu. New menu will change, the number of these lines will be created. Now Python 3 terminal, that is the terminal will be. So that means this option started with OS dependent terminal on Windows. It opened the particular either by DOS or other kind of operating system. Python 3 kernel can use started from the menu, which is essential for running Python code. So at least one kernel must be active to execute the Python command. Additionally, other kernel also can be installed and support the different programming language beyond the Python. That is the case will be here. Now running tape. Then the tape will display all active terminals and notebook kernel that have been started but not closed. This is the cell. So here one plus command will come. You can create multiple cells. Okay, so and then we can do the run. So by the run command, we can just execute the statement. So you can just see whatever the statement will be written, that run by run. So this is the primary interface, include menu for various operations. Most importantly, cell for writing and executing code. So this area is called cell. And if you click here, one plus button will come. You can create multiple cells while creating of new programs. So Jupyter Notebook, the cells will be created. The text in the can be. This is the like you have written print hello world, print hello world, print hello world. So cell is using code instead of markdown. Syntax highlighting the help distinguish between different elements of the code. The in is indicate that code will be there in cell with number inside the bracket. So this in will be there. One cell, two cell, like that. Multiple cells will be created. Like that. This is the 4 into number. So number already declared in one cell, and 4 into number 42 will take. 42 is what? Variable. 42 into 3 output will be displayed. Like in MATLAB, what you are doing command from 4 into 4 output will come. So likewise cell, there are multiple command will be written. So 4 into 4, 4 into 4 into 4, all output will be displayed in output cell. Input cell, output cell. So multiple cell will be created to execute the Python code. So likewise, if you install any already executed program that is already available in a particular cell, just one by one cell you have to run it. Then it will run. Otherwise, if it not run, it will give the error. If the library is not supported, if library will be outdated, or if library not executed. That is the procedure point of view. Now, stopping the Jupyter Notebook, save the notebook. So you can save the notebook, you can shut down the notebook, you can stop the server, you can interrupt the notebook also. Because notebook is running through kernel. In backend, that process is going on. That means you can click X command, and that on the browser window is not sufficient, then it does not shut down the notebook server on the kernel. So notebook will continue running in the background. If you not stop, notebook will run background because it is running by kernel with backend side. So that you have to stop it. So if it is necessary to return later, then browser can remain open without needing to shut down also. If you don't want to close the notebook, once you start again, notebook will be the same position. So that will be the case here. So now this is the Jupyter Notebook. Now here we can see, here we can go in particularly save the checkpoint, revert the checkpoint. These are the, so this downloading and exporting the Jupyter Notebook. That means you can save the notebook and you can use another system also, or you can transfer the notebook also. and sometime you want to run that notebook through Google Colab. So you can use that one also. Suppose you are going some other place, you don't have laptop, you will get some system there. Through Google Colab, you can access that notebook also. That means you can download, you can export in future purpose. So you can that use it. That notebook also will be possible. So we'll see the experiments on the system. Okay, so one more part is there. How we can execute the so data reprocessing and feature engineering. That is the main important part when we are doing the machine learning for any kind of data. Here we are going to concern about energy data. So what is the pre-processing? As we have explained, it is the data mining technique. Basically this technique is responsible for transforming the raw data into understandable form. That means the data must be suitable for further processing. That means you have to clean the data. That is the procedure. Like in terms of many way the data would be lazy data or like noisy data. So we have to clean the data, and the data must be suitable in particular understandable format. That is the requirement. So we have to perform the data pre-processing. So after that we have to, why we process the data, what is the necessity of pre-processing? That means data in the real world incomplete because the error, because of the lacking values, certain attributes of interest or noisy. It may contain the error or outliers. Outliers means you are classifying, suppose this group of the people, that group of people, and people are aware from the last, that is outlier, that will not come in this class. So we have to neglect them, or if you consider them it will be difficult. So in that situations the error will be more or inconsistent. Data is inconsistent because of lack of incompatibility or similarity between two or more facts. No quality data. Whatever data we have collected, no quality mining result, quality decision basically depend on the quality data. And data warehouse that needs consistent integration of quality data. That is very important. So because of that reason only data pre-processing is required, particularly for renewable energy data set. It's a comprehensive data. So a guide to data pre-processing technique for renewable energy data set. It covers the importance of data quality, what are the challenges are there, what are the cleaning requirements, and we are going to transform them. And after that we have to integrate. So comprehensive guide has to be explore the feature selections and best practice for renewable energy data. So basically what is the procedure? If you are a machine learning engineer, you must aware we have first data collection, then data pre-processing, then feature extraction, then feature selection, then perfect classification by applying various algorithm. Then you have to select which algorithm will provide the best result. Finally compare the result by the classification report generated by result in terms of confusion matrix. So if you are writing a paper, in the paper your basic terminology would be quantitative analysis or qualitative analysis. Quantitative analysis means parameter, what you have observed, what you have received, and what you have compared with state of arts methods. Similarly, whatever the graph you plotted, whatever the result you plotted, that is qualitatively analysis in terms of images, in terms of signals, or in terms of various plots. So by that way you are presenting your result. So confusion matrix will be the final classifier report in terms of receiver operating characteristics or in terms of various plots like a loss plot or like a accuracy plot. So these are the analysis we are doing in terms of accurate analysis. So that means importance for data quality is renewable energy analysis. High quality data ensure that more precise renewable energy analysis, and reliable data leads for better decisions and strategic planning. And clean the data, improve the accuracy of predictive model. If you create a model with false data or with noisy data, you will not get correct result. So you have to clean the data. So data quality is vital for reliable energy analysis. Accurate and consistent data will improve the decision making capability. So it enhances the effectiveness of predictive model. So whatever your predictive model will be there, it will improve your predictions. It improve your decision making capability. So particularly if suppose any missing values are there, incomplete value will be there, or any outlier will be there, or any inconsistent format will be there. So energy data set often suffer from these all issues. These issues are there. Always remember, these issues will come for every kind of data. Outlier may be there, missing data will be there, error will be there, noise will be there. Like you are transferring speech signal, like you are talking someone. Sometimes you are listening to voice. Your voice also you are listening 2 times. Your friends are not able. Your friend is listening to voice. That is noise. So noise definitely in terms of signal will be added either by your device, either by your component, either by channel, either by weather, either anything. So that is the data. If data will not be perfect, you may not be able to generate the predicted result. So these are the format will be there. Then input, replace the missing value with statistical estimate. Then deletion, sometimes remove some row and column. And outlier we need to remove. So identify, eliminate extreme value using statistical method. So effective data cleaning, we have to handle the missing value or use input or deletion and address the outlier by removing the extreme value, or these steps remove the data quality. Like data transformation. So we have to transform the data. So you heard about Fourier transform. Everybody utilize Fourier transform, cosine transform, Veblen transform. Basically we are transforming. So normalize the data. First what you are doing in terms of data processing, first you are going to see the data, then you are applying the data by normalized way. By how the normalization will take place? Divide by 255. So the data would be converted 0 and 1. So normalizations, then feature engineering. So we have to create new features from existing data to improve the model performance or scale the data. Sometimes adjust data to common scale to avoid the dominance issues. So data transformation method include normalization and scaling. This technique will make the data in standard format. So that means we are going to standardize the data. Feature engineering basically will create the new variables. That is the main important part. So they are creating new variables, and this method enhance the model accuracy. So with feature selections, one feature is extracted, we have to select. Selection is one of the requirements. So feature selection use method like correlation analysis and machine learning. We are employing the machine learning to rank features by importance for model predictions and domain expertise. So we are going to leveraging the knowledge to select variable with practical significance. So feature select, identify the relevant features, relevant variable which are important. Suppose we have selected many features on the face, but which are more important feature? This eyebrow, this nose, this chin. Other than features are not dominated, so we will remove it. So principal features will be computed. Likewise, many features are very important. So selection will be very important. So employing the statistical test and machine learning, and we are going to leveraging them to a domain expertise to improve the accuracy and reduce the complexity or focusing of essential features. So likewise, we have to standardize the data. We have to harmonize the data and validate the data. So data integration, combine the information from multiple sources. So this process involve the standardizations, harmonization and validation. So proper integration ensures that data consistency, and also it supports the comprehensive analysis. Now addressing imbalanced data. Sometimes data is not balanced. That is also problem of overfitting. So techniques are required for handling such event. Resampling, cost sensitive and algorithm. So imbalanced data require spatial handling. So resampling technique balance the classification of data distribution. And cost sensitive methods also sometimes will penalize the misclassification of rare event. An algorithm will adjust the model parameter for case of data imbalance. That is the main important one. Like you will see the case study, real world example of data pre-processing for solar and wind energy. Solar energy, so enhancing the solar irradiance predictions, improving the power output forecast. And wind energy, optimizing the wind turbine performance by reducing the uncertain wind speed estimation. So real world example highlight the data pre-processing benefits. Application in solar wind energy show the improved predictions, and proper pre-processing optimize the renewable energy system. So we will continue after tea breaks. So after that you can just do the hands-on on the system at least for half an hour. Okay. Just take the snacks. Eat. just train the model, then save the model, then test it. This is the procedure will be there in terms of file. But in terms of MATLAB, I say learner app will be there, export the data, same way feature extraction block will be there, execute, same way machine learning blocks will be there, execute, same way result evaluation block will be there, create the confusion matrix, see the result. So based on that, various model can be created. And we can visualize which model will be best fit. So it is not necessary every time same result will come with the same model. Sometimes KNN will dominate, sometimes SVM will dominate. Features are also you have to identify selected features, dominant features or optimal features. Then various classifier, you have to create the algorithms. Then you have to train the model. After training, you have to check the loss. Loss is going to reduce, accuracy is going to increase, and various performance metrics will be computed by confusion matrix. So classification report will be generated. After saving, the model will be trained model. Then you can use that model for unseen data. That is testing. Okay, so this way we are going to see certain program. So just half an hour, please execute the program already there in the system. Just see the process will be given by the scholars, and please perform the activity. So please start and execute. Okay, so half an hour, 45 minutes, just do it. After that, you want to access the system for your other work, research work. Till 5.
On your desktop, like 4 folder is already installed. Just go to Anaconda platform, just Anaconda software is installed, press that one. After that you can see this kind of environment. That, as sir was saying, we will be having different interfaces where Jupyter Notebook, Lab and R code, R Studio, everything like Spider. So what is flexible to you, you will be using, and mostly we will be using with the Jupyter Notebook. Say this Jupyter Notebook to press that launch one thing. Press that. Press the Jupyter Notebook launch. I'll open this Anaconda one now. It all got this window. It all got this one. This is like how your Jupyter Notebook will be opening in a local repository where if you don't require any net also, already predefined course is executed. So, and here you can see one thing like new upload. If you want to upload any like already .py files, you can press that upload file and you can open directly. And here you can see this new option where if you want to type any new kind of code, you can press this new one. So then it will be opening like this. So it is a platform where here the Jupyter Notebook will be visible. This is called as cell, where want to type any simple print, one, type one basic any small number code. Then after that, you can press shift enter. Then it will be executed. Right? Did it all got this print high? Yes. So similar thing. Here you can see this run, and you can see different files also, editing, insert cell, tensors. This is basic where codes, bulk codes could be executed, and when you are doing code, if you do in a part wise, cell wise, that will be very easy for you to sort the error where it is. Right? So this is simple how the Jupyter notebook book will be visible for you guys. Now we will be opening three different codes which we already executed. Go back. On desktop, you can press this desktop one. Here you can see codes one folder. Already few codes which are executed has been placed on your desktop. Open that codes folder, and here you can see like forecasting and time series kind of data. .py files could be visible here. You can press this time series forecasting data folder, and you can run one. This all like already sir was saying you few libraries, right? You can see that libraries, pandas, numpy, matplotlib. So matplotlib for your graphical visualization, numpy for numerical operation, pandas is for some numerical operations. This is how if you do in each and every cell, first you insert all the libraries, then after that, while you are running, you can press shift enter. Right? And later, first step could be loading your data. So in folder also already pre-defined codes were also loaded also.
Madam, we need to launch Jupyter notebook, right, ma'am?
In code folder we kept data set also. One see how the data set is there, how this model is giving, how it is executing. Simply see, because before while you are doing anything, first libraries are must, then data should be like pre-processed, then what we want to extract exactly, we need to identify those things. Then we will be applying specific model. It could be CNN, deep learning, some other model. Then we will be doing some prediction kind of thing. So that this is the only simple data set what we took, XGBoost algorithms applied for forecasting kind of data. Just try to learn basic codes, how it will be, something like that. Just visualize the thing. And data set is on, and two codes are there, right, Priya? We have two codes, no? You can see three codes are there. Please run that three codes. Maximum it will be running itself. You won't face any error, but explore the things how they are installing in each and every cell. What is going on? Just observe those things. Okay, it's happening for you. You guys can do. It's open. So this is first thing how libraries services because from basic we need not to write the code. We will be taking few already predefined codes where in these libraries it will be there. So when we will be required, we will be calling those libraries and reading. This is how we are reading our data CSV file. Data could be in images, data could be in tables, and data could be in some other format. Now here the data maximum will be in CSV integrated form. So that data you can see this data set in desktop also folder. So that data is loaded here. Then and here see how data is visible. What are the extra features are there? So based on a specific time, we will be predicting if any like temperature, humidity kind of thing is there. What will be like what could be your power consumption? Some other unknown parameters there, but based upon previous data, we will be analyzing. It could be happen like this if any parameters are. That is the advantage of machine learning, where and any missing values we can identify, something like that. So this is like
We need to navigate to the desktop folder now from here.
Yeah, go to desktop.
And next, this is data and this is like any missing history column, something like that we'll be doing. And this is like correlation matrices. These are like different labels we have. This is confusion matrix. So on previous classes, sir was saying about the confusion matrix also, no? Based upon that only we will be analyzing exactly true positive, true negative values. We will be finding our accuracy. Our main intention is to predict something which is like based upon the previous data. That prediction could be possible or analyzed using this confusion matrix itself. So if you are predicting two kind of thing, we will be having 2 by 2 matrix. If with 3 kind of prediction, 3 cross 3 matrix. So your true positive, true negative kind of calculation could be done and accuracies could be there. That matrix also you can see that. MATLAB also. MATLAB also we can do this prediction, classification, regression, and deep learning also. So based upon our requirement, our research area topic, we can do the platform in which you want to do. So just learn the platform, how it will be, how libraries will be, and how this basic flow, time series, data visualization will be taken. This and description also written there. You can read those description also. Collab also. In online collab also we can do. In collab, I will share one link to you where basic course will be there. How many of you know collab using? Google Collab using? So I'll be sharing those. In that, just load the data, see that regression, SVM basic will be there. Once you do hands-on practice, tomorrow if you have any queries, we'll do that. I'll share that everything code will be there, data set will be there. In Collab, you need to open and load the data and execute that. Change the path and do. That's it. And all the certificates details are fine to you now, right? Whoever here? Doubt? Because I'll be sharing the certificate details today. Exactly, we know that this if you this one is dog, this categories will be given. That we only we have two types of category are given. But if you have this little mix in that dog cat is there, some other animals and the butterflies are there. In that separate the output labels we are not giving. Without giving specific reason, that we will update. Getting updated in that could be so what label and mixed. Mixed one is random. So this is will be having mixed. Then you have to update the library. Sorry, reinforcement. So Collab will be also label and unlabeled. So we can take some static kind of take the static. So
what they have provided. So unlimited storage everything. So I can directly switch to Collab.
And then education qualifications.
Yeah, that will be that's an unlimited storage college is providing us.
Unless until you are using like image data set and very big data set, you will still little slow, but otherwise Collab is fine. Collab is fine.
So if a person is having 10 years of experience, he can system, and model will be understanding what are my features, these are features. What I need to fill up, salary I need to fill up. This model will be plotting some graph. You can understand how this protection, but internally much mathematical will be going on. Simply I am saying that, but internally much mathematical operation will be going. That's so that deeply later when you are going towards this work, you will understand. So some it will be having some which are having like 20 to 30 will be plotting some clusters, something like that. So if you want to have 4 years, it will be middle. So it will be doing some GIAN. So it will be mapping which is near. It is near to this one. So it will be giving some 50 to 60. Based on the algorithm, we need to understand what is the mechanism behind the algorithm, which algorithm is useful for specifically predictions and other kind of things. That analysis, if we are going to deep, if we are doing towards this deeply understanding about one algorithm, then we will be understanding. So for this we have different features, right? In this kind of features, exactly we want to find any one output to find exactly power consumption, the zone we want to identify. So based upon this, I will be taking this prediction. In that, we will be calling training and testing. Exactly, our data will be 100%. 70% could be training, because without training, our model cannot understand data. So we will be reading and understanding the data, and 30% would be testing, which is in exam. Suddenly, if you are going to teaching in classroom, we will be giving 100% will be teaching, but 70% known syllabus, 30% unknown syllabus will be. If a person performing the 30% very goodly, then the model students are good, right? If a person known question, if I give that is useless, obviously they are getting good marks. That is the model. So if we train in this, this is not good. Obviously, known paper is given for you, 100% will be writing good. If an unknown paper is given for you, then also if you are getting good accuracy, then that system is called good accuracy. So our model must be like that. So still we have machine learning with deep learning. Deep learning is still a bit of complicated, where much huge and complex kind of data, like image kind of thing, still deeper. You want to analyze, still deep analysis could be done. Then we will go for deep learning kind of. All are interfaced into one merge. We will be taking some time to understand, not that much simple, but slowly, at least you can know like overview like what will be the how some terminology you will learn. So start learning all these things individually, creatively. We need to train them on data. It will understand. It will predict something what will do. This could be done in MATLAB and Anaconda platform. So tomorrow we will see MATLAB. MATLAB is still very simple code. In here we will be writing all code. No, in MATLAB we won't write any codes. We'll give data set, and there are already 3 different classifiers and equations will be there. Just we need to know. We need to divide this training and testing kind of thing.
But one point, ma'am, if we are doing MATLAB, for example, some sort of PhD one, then
Not that much useful. Accepted, but not that much. Only we have MATLAB regression and classification kind. That's what. Not for PhD, but this general local conference purpose it will be done. This is testing the model at 78% accuracy or 95% accuracy. How can you say this thing? Our system is saying this thing based upon the correlation to confusion matrix. So we will be having 0, 1. If it is we want to only dog and cat matrix, 2 classification, I will be having 2 cross 2 matrix. Here it is having many, that's why it is having many features. How many, what you want to predict, that many we will be having that type of 9 to 9 cross confusion matrix will be there. So what is this 2 cross 2 will be false positive, false positive, false negative. We are doing total samples to be divided in this 2 by 2 with exactly if it's my samples are 120 equal will be distributed. So that's what the model of training it will be giving us. Accuracy equal to total true positive. I think here it also subject true positive, true negative by total samples. By total. So that will give us some percentage. So that is called accuracy. So
So we will be doing evaluation manual. After doing everything, we need to analyze what is happening. No? That analysis could be possible. That is called evaluation. Record, accuracy, and correlation, interconnection between one and one. We need, because after doing everything, at least we need to give some analysis kind of thing. No? That kind of thing, we will make some evaluation kind of things. Teacher evaluation. For the specific teachers and in that we can see that all teachers have like we have 10 to 15 teachers, but only few teachers are very important for your model. For the words and that for classification also, eyes and the specific teacher is fine. And any texture color is fine. Remaining all features are not that much important. Which are more important. We will be seeing, we have some selection models also, feature selection model. If specific features are really similar type of accuracy, then why to train with 100 features? When training with 100%, taking more time, getting 78. When training with same 4 features, same 78 and get it. Right? Your time is saving, right? We will know exactly what are good features which we will be using for our prediction. That are the feature selection methods to do that. Which are like more important, much important. What are the essential things they are taking, which will impact a prediction or analysis kind of thing. Yes. That time we are seeing the values how it is like now we can only specific features that one and some pre-process kind of thing. Some we are doing some chaotic rolling the values. It's like features kind of thing. Because a model will be mean, median, variance, all these mathematics, all these standard deviation, all this like feature kind of calculation for the system to understand. So now I was saying this one. In year one it is saying this is near, that's why it is to prediction. How this near calculation is done based upon mean, median, various kind of thing. There the mathematical will be internal purely mathematical will be involved. Outstanding we can't understand. Internal mathematical will be involved and based on that we will be
ఎవరు దాని గురించి మాట్లాడట్లేదు కాలేజ్లో ఎవరు దాని గురించి ఏం మాట్లాడట్లేదు మేబీ రేపు మాట్లాడితే నాకు
Yes. And instruction has been given and lab కి ఎవరు ఇన్ఛార్జ్ ఉన్నారు they have to take care of everything. అది అదే కమ్యూనికేట్ చేసేస్తారు. అగైన్ NBA పని అవుతుంది కాలేజ్లో ఆల్ ఆర్ ఫోకస్ ఆన్ దట్ ఓన్లీ. ఏదో మీటింగ్స్ ఏ రోజులో ఏదో అవుతుందంట. So they are focusing to that thing. I think tomorrow it will be again they will be focusing on this thing.
ఇంటర్నల్గా జరిగింది ఇంటర్నల్ బ్యాక్ వెరిఫికేషన్ జరుగుతుంది.
Okay.
బ్యాక్ వాళ్ళు వచ్చి డిపార్ట్మెంట్ బయట వెరిఫై చేస్తారు. అలా ఏదో సిఎస్సి వాళ్ళకి
So tomorrow morning again at same morning we'll be having hands-on here first. Afternoon we'll go for hall. Morning you gather here itself. Morning tomorrow we'll do on MATLAB. And I'll share that link also. You can practice that link also. Collab link. Please come 5-10 minutes early itself. Sir is getting angry. Please come 5-10 minutes early. Okay? Just 1 or 2 days to go. You'll be getting energy. Okay? Thank you all.